So we will be having like 30 sessions. So in each session we will be having some topics like this. So in this first session we are going to cover like what is Tableau and why are we using Tableau, and what are the Tableau products we have. And Tableau has a capability called in-memory BI tool. So it is called as an in-memory BI tool, and we are going to know the reason why it is called as an in-memory BI tool, and some basic functionalities. So fundamental functionalities. So while you are connecting to SQL or any BI tool, so we will be having dimensions and measures, and we will be having OLTP and OLTP. So these are the topics that I'm going to cover today. Yeah. So as you are aware about this Tableau before, like you've been having some bit of knowledge on this. So Tableau is a software company which is headquartered in Seattle, Washington, and recently it got acquired with Salesforce. So the main agenda of Tableau is to help anyone see and understand their data and connect to almost to any database. So there are multiple databases that it can connect to. Let me just show you Tableau. So this is the Tableau application. When we open this, we will be it will be asking for Tableau registration and all. So I will tell you how. So do you have Tableau in your PC right now?
Not on this PC, but I have another PC. Let me look.
Okay, so do you have license for it?
No, I don't have license for it.
Okay, so there is a procedure where you can get a license for student. Okay. So I will tell you that procedure. With that, you can get a license for 1 year.
Okay.
So with that you can use.
Oh, I think right now I have the expired one. Can I use that one as the student one for 1 year? I recently installed 1 month back.
So Tableau by default it comes with a 14 days of trial version. Yes. So after that 14 days, you can't use that again. So what you need to do is you can install a later version or a preview version. So that you can use 14 days.
Okay, yeah. I'll try to uninstall that one and I will do the previous version. I will install the previous.
Okay. Yeah, so Tableau is having its own patent language. So let's write it down. Just a second. Okay, so Tableau is having its own language called VSQL.
Okay.
So, which is nothing but visual query language.
Okay.
So basically what it does is it converts data to visualization.
Okay.
So anything that we create, it will automatically convert the data into visualization. So in the backend, it writes SQL queries basically. So VSQL is nothing but data plus visualization. So VSQL is a combination of SQL and descriptive language for rendering the graphics. So any data in the form of text, it will convert into visualization.
Okay.
So there are many reporting tools. So this is Tableau is one of the reporting tools, and we also have other reporting tools like Power BI, ClickView, and there are Cognos and all. So apart from all those reporting tools, why are we using Tableau? So there is a specific reason that we are most of the clients are using Tableau. So the graphics and the visualization, the look and feel, everything is well and perfect that everybody is using Tableau. And apart from that, we also have powerful analytics. So we can create interactive and visually looking good dashboards, and we can answer any business questions. So whenever we see data, so if we push that data into the Tableau, it can give solutions to that data. So it can solve the issues, and it can highlight the problems in the data, so that users can take action on that.
Okay.
Yeah, so it is powered by a patent visual technology, which I told you before, which is visual query language. So that is one thing, and fast adoption at scale. So what does that mean is we can connect to any data. Let's say if you have data in some SQL table or Oracle table, or if you have any flat files like Excel or any notepad or anything. So you can directly connect to that database, and you can start building the visualizations.
Yeah.
Okay. And it fits your environment. So it can connect to any data, and it can connect to any of the platform. So when I say environment, I will tell you. So there is on-premises and cloud. So Tableau can be maintained in the on-premises servers. So this is nothing but servers. So we can use on-premises servers or cloud servers like AWS or Azure. Okay. And we also have Tableau online also. So which is maintained by Tableau company.
Okay.
So when we say AWS or Azure or on-premises, this will be maintained by our organization. But when I say Tableau online, it will be maintained by the Tableau company. So we just take the data, or we just take the space from the online, and we just use it and share it with the customers.
Okay.
So it fits our environment. So most of the clients or most of the customers are using AWS or Azure or on-premises servers. So it can connect to any database or any on-premises or any cloud services. And it can also be used in. Am I going very fast, or do you have any questions?
I can't hear you. Can you repeat one more time? What is that?
Am I going very fast, or do you want me to slow down?
No.
Okay. Okay. So we can connect to Windows or Linux or Mac OS. It will support all the OS, and mission critical platform. Like when data is critical to our business, like it can handle like millions of records, and the data is so secure, and the maintenance of credentials and everything will be so secure, and it maintains the compliance and security management. And Tableau also offers and supports the needs of our businesses. Like when we are sharing some data to the customer, so it will directly be shared to the customer itself. And there is a like we can give security, like data security. Let's say if you are sharing any data to the CEO level, so he can access the entire data. And when you are sharing the data to the contact or any particular regional head, so he can able to access only that his particular region's data. So we can restrict the data to that level of access that they have. And let's say if you are giving access to some manager, so he should be having access only to the his team members. She should not be able to access another manager's team members. So there is a restriction, and we can give row level security by providing the Tableau server. We can restrict the data to the specific persons. Yeah.
Okay. Yeah.
So we have so many Tableau products we have.
Mm-hmm.
Let me tell you. So Tableau products. So Tableau desktop. So Tableau desktop is the main one, and Tableau prep, Tableau reader, Tableau public, Tableau server, Tableau online. Basically, these two are very important. So Tableau desktop and Tableau server. These are the two products which we use mostly. So first, let me tell you about Tableau desktop. So this is where the Tableau development happens. So the application which I opened here, that is what is Tableau desktop. And this is where we create the visualizations, and it is core platform for all the Tableau developers. So whoever uses this Tableau desktop, they will be called as Tableau developers. And we can create actionable insights by creating the visualizations.
Okay.
So this is where the development happens, and this is where we connect to the data, and this is where we pull out the information. And so this in Tableau desktop there is a functionality called it will separate the dimensions and measures. I will tell you about what dimensions and measures in the next slides. And yeah, so after creating the visualization in Tableau, let's say we created one dashboard in Tableau, and it is in our desktop. So we want the users to look into the dashboard or the visualization that we created. So we need to have a platform where user can go and see the dashboard that we created. So this is what the platform. So where we publish our reports. Tableau server is a platform to publish our report where user can access.
Okay.
So it's like sharing our information in the Tableau server, and this is they can log in only with their credentials. Or there is a functionality called single sign-on. Single sign-on is nothing but, so they don't need to enter their credentials every time. So it will automatically pick up their system credentials, and it will directly show their data to the customers. So it will not ask for any credentials. It will directly open the Tableau dashboard. So by taking the Windows password. So Tableau server is where we publish our reports so that user can access the dashboards which developer develops. And so that is about Tableau server, and this is where we restrict the data, and so that we can put some low level security, so that any user logs in, and so he can see this particular data. Let's say a regional head logs into Tableau server, he will be able to see his region's data, nothing but the other regions.
Okay.
And yeah, so coming to Tableau prep, Tableau prep is like preparing the data. So, so earlier to Tableau, like 10.3 before, we don't have this Tableau prep. So recently they have implemented this Tableau prep. So this also needs another license for this. So you can't use Tableau desktop license to the Tableau prep. So you need to have a separate license for Tableau prep. And
okay, I understand we want to use a different license. What is this prep? Tableau prep?
yeah, so where we can do data modeling. So here we can do, we can do left join, right join. So we can do all the types of implementation and we can run the steps. Let's say you take the data from one system and you take the data from multiple systems and make it together and combine the columns, do some operations and all. Everything happens here, like an ETL job. It extracts the data.
Like a what? Oh, ETL. Okay.
Extracts and transforms.
Okay.
Loads into one table or anything, like any database.
Okay.
So it does an ETL operation. So basically, in any organization, they maintain some ETL tools, any SQL database or any.
Yes.
So they'll use this ETL kind of stuff. So we don't use Tableau prep much.
Okay.
Yeah, so this is not much useful. And there are Tableau prep developers are they will be separate. So they have to do the ETL operations and all. This is like we will have jobs to run. So if you want to load the data into some particular database, so you need to run this job.
Okay.
So every monthly or weekly, so that happens.
Okay.
So that's why I said in the starting, Tableau desktop and Tableau server are the two main applications that Tableau developer use.
Yeah.
Okay. And Tableau desktop is a licensed version, and per single it costs I think $70 for single license.
Okay.
For group it might differ, and Tableau server for each and every credential, like for one user they might charge something. I'm not sure about that logistics, but they will charge for each user. So let's say if we have 100 users, they will charge for each and every user and multiplied by 100.
Okay,
So
that's
in that, sorry.
Yeah. Okay. Yeah. Okay.
So that and even Tableau Prep is also a licensed version. And so coming to Tableau Reader, so this is a free version. So anybody can install Tableau Reader, anybody can use it. There is no license required for this Tableau Reader. And this is to just read the Tableau files. So it's like a PDF reader. Let's say if you want to open a PDF file, you need to have PDF reader in your computer. In the same way, if you want to open a Tableau file, you can open with a Tableau reader. So if you have Tableau desktop also, you can open it. But for Tableau desktop, you need to have license. But for Tableau reader, you don't need any license. But you can't do any edits. We can't edit in Tableau reader. Likewise in PDF reader, we can't do any edits, right? Like we can't change any text or anything. The same way in Tableau reader also, we can't do any editing and it's just to view the Tableau files.
Yeah.
View the Tableau files. Okay. So Tableau public. So this is also similar to Tableau server, but this is maintained by Tableau company.
Okay.
So if you publish anything in this Tableau public, it is viewable by anybody in the world. So anybody can see in the dashboard that you publish in this Tableau public. And So it is like just to practice. If you want to practice anything, as Tableau server is not free. So if you want to publish and if you want to see some transactions or anything, you can publish it here. And uh, yeah, looks like you can practice over Tableau public. So it is viewable by everybody. Yeah. And Tableau Online, it is a hosted version of Tableau server, which is maintained by Tableau company. So Tableau Online, what it does is it gives the space from online. So let's say if you are publishing 100 dashboards, so they will give you space for that 100 dashboards, and they will provide you some number of users. Let's say if you want some 100 users, so they will give you for 100 users, they will give you some amount of space. Let's say 100 GB or 200 GB. They will provide you the space. So in that space, you can publish the dashboards and you can host it in the Tableau Online. So you don't need to make any servers. So let's say if you get any issue in the space or anything, you can raise a complaint to the Tableau company. But in case of Tableau server, we need to maintain the server. Let's say we need to have some 1 TB or 2 TB or whatever data which is there. So we need to maintain that much of servers. That is our headache to maintain the Tableau server. But in case of Tableau Online, it is maintained by the Tableau company. We just need to take the space. And this is all cloud.
Okay.
And in case of Tableau server, this can be on premises. So we in most of the organizations it is on premise right now. Now they are moving to cloud, which can be most of them are using AWS and also Azure.
Okay.
Yeah. So this can be two. Tableau server can be on premises or cloud.
Okay. Yeah.
So these are the 1, 2, 3. These are the 6 products which are there for Tableau. So most of the we use only Tableau desktop and Tableau server.
Okay. Yeah.
And in Tableau desktop, the main feature is like it harnesses the flexibility. Let's say it will calculate the calculations on the fly. On the fly in the sense, let's say we have a calculation. Let's say we have a column called column 8. And we also have column B. Column B. And you have values like 23, 32. And in column B, you have some 20, 40. And if you are doing division like column A divided by column B, so normally what any database, yeah, it does like this. Something like this, and it will give you some output, some decimal output, whatever it is. So it gives us the output, and it stores in that column. So in Tableau, what it does is, so this can be manipulated. So we can write calculations, and this can be manipulated for each and every region. This will not be stored. This value will not be stored in the in a database or in a table. It will not get stored. So let's say what happened. Let's say if now you take the total. So 23 plus 32 is 55, right?
Okay.
And which is 60. And here you can't do the sum up. Let's say you have some value like 0.2. Maybe I'm just entering some random value. Maybe the answer is 0.4 like this. So normally database what it does is it might give you 0.6 as the answer as we are summing up, right? But actual output might differ. Let's take the right values only. So 23 divided by 1.15. And 32 divided by 40.8. So in this case, what I'm doing is I'm summing up 0.8 plus 1.15, which gives me 1.95. So I'm doing this summation. So in case of normal databases, what it does is it will do like this. But sorry.
Yeah, go ahead. Nothing.
Okay. Okay, so Tableau, what it does is it will do this summation, like the column A summation and column B summation, and then it divides. So 55 divided by 60, it gives you 0.9166, which is correct.
Yes.
So whenever you do a division, you need to do the sum up and do the division. So as I said, Tableau does not store any values in the backend. So it will do the calculations on the fly. So when it is a individual values, it will give you individual division. But when it is a summation, it will sum up the data to that column and to the other column, and then gives you the value. So it does an on the fly calculation. I'll show you in the Tableau desktop in the coming session, so you'll understand more better. So these are all about Tableau products, Tableau server, and all that. Yeah. Okay. And as I said in the starting, so it also has a capability as an in-memory BI tool. So this is much more important in this Tableau. Why? Because it uses RAM instead of pulling data from source. So it stores the data in the RAM. So that is why it takes less time compared to other BI tools. So let's say you are connecting to some 1 GB data or 2 GB data. So what happens is every time it hits the tab at the database and it pulls the data. So it takes a lot of time to show the visualization. But in case of Tableau, what happens is it hits the RAM. So the data will get stored into the RAM, and then it will take the data from our PC only. So in that case, what happens is it is taking the data from our PC, so it is so faster, and it will show the visualization very faster compared to other BI tools.
It's on the Tableau desktop, right?
Yeah, Tableau desktop and Tableau server as well. So Tableau server also, if you have, so it depends on the RAM. So if you have more RAM, your dashboard will be faster. If you have less RAM, your dashboard will be slow. So you need to maintain the RAM. Depending on that, the performance differs.
Yeah.
So the advantage of this BI in-memory BI is it improves the processing speed, and it is not limited to the displaying only the numbers in the cube. It also stores the data in the RAM.
Okay.
And yeah, we can do complex calculations also by using this in-memory tool. Okay. Yeah. And coming to dimensions and measures. Yeah. Dimensions and measures. So these are the fundamentals. So any database or any reporting tool, if you are learning any database or any reporting tool, these two are mandatory to learn. So dimensions are the ones which cannot be aggregated.
Yes, because those are names.
Yeah, these are mostly names. Names, regions, IDs, and date. All this comes under IDs. If you see, IDs also, it seems like numbers, but let's say you are having some number like 140514, but that's an ID. You can't do a summation. Let's your ID and my ID, we should not do a summation, right? So,
yes, yeah.
So likewise, date is also a dimension and measures. So in the name only it is saying which is measurable
Okay.
or which can be aggregated. Which can be aggregated. What I mean by aggregation is nothing but some
division, multiplication, yeah.
division, multiplication, where we can do all these mathematical calculations that we can do. We call that can be aggregated. Let's say sales, profit, uh, ratings. Yeah, all this can be measurable. So dimensions and measures. So whenever we connect Tableau to any database, so first of all, what it does is it identifies the dimensions and it identifies the measures and it will segregate. Let's say in case of IDs, if you see, I'll just open one Excel file. So in case of IDs, what it does is it looks like a number and Tableau identifies it as a measure. So Tableau won't understand whether it is a dimension or whether it is a measure.
No.
So we need to tell Tableau that it is a dimension.
Okay.
So there are certain things which we can convert from measure to dimension, and dimension to measure.
Okay, yeah.
That I will show you in the coming classes how to convert that. Okay, so ID. Something like this. Like this. And name Ajay date. So this is the sample data, and we have, let's say, salary, $500, $600, $700, and wage. Okay. So in this, can you tell me what are all the dimensions and what are all the measures?
The names and dates are the IDs, and names and dates are the dimensions, and age, salary is the measures.
Yeah, correct. These three are dimensions, and these two are measures. Okay. So this is the fundamental of any database or any reporting tools. So we should know about dimensions and measures.
Okay.
And as I said before, so Tableau won't identify this particular thing as a dimension, sorry, measure. So basically it converts this as a measure. As we have numbers in this, Tableau will understand that as a measure only. So we need to convert that into a dimension.
Okay. Yeah.
Or in the database, if it is specified as a character or any text value, so then also in case of that also it will convert into dimension. So let's say if you are saying it here, so it is in the format of general. Let's say if I am converting into some text. So what happens? It became a text value. So Tableau now it will identify it as a dimension only. So database also there are some format options where we can keep number also in the text format, so that Tableau also identifies it as a dimension. Yeah, so measures, as the name suggests, which can be measurable and aggregated, and measures are numerical values where we can perform mathematical operations and all. And so, okay, and the main thing is uh, dimensions are quantitative and measures are qualitative. So, as you said, you are going to prepare for the interviews, right? So these are some basic questions they ask. So they might ask you about what are dimensions and measures. Yeah, sure. So if you have any questions or any doubts related to your requirements, you can ask here.
Yeah, sure. Yeah, I will.
Okay.
And also we are going in a good shape, so yeah, we'll continue.
Yeah, okay.
Yeah.
And OLTP and OLAP. So these are also two basic fundamentals in database level only. This is not related to reporting. So OLTP and OLAP. I'll just write it down here. OLTP, online transaction processing. So this is where all the transactions happen. Let's say in Amazon or Flipkart or in any ATM or in any super store. So whatever the transaction that we do, that transaction will get stored in this OLTPs. So the data will be stored for temporary, like for weekly or for daily. So they store the data. They store the data and they transfer the data to OLAP, which is online analytical processing. So in the name only, it is defined like transactions. So wherever the transaction happens, let's say if you are buying any phone in Flipkart, so there is one transaction which is happening. And so a lot of transactions like editing, like deleting. Let's say if you are buying any products, one record will be entered in that transaction table that this particular person has bought one particular phone, and that let's say if you are canceling that product, some editing will be happen in that transaction, and that let's say if you are not buying any product, so that record will get deleted. So every transaction will happen, and every user will have interaction with this OLTP. Let's say I can interact with Flipkart, or I can interact with online any uh, e-commerce websites. So any user can interact with OLTP. But in case of online analytical processing, what happens is all the transaction tables information will get stored in OLAP, and not all the users can access this OLAP. So it will have historical information, and this can be used only for analysis purpose only. Let's say the data that we use for Tableau. So we take the data down, and then we create the visualization, and that data will be accessible to the customers, let's say to the higher level management, or to the managers, or to the leads, but not to the user level. So user cannot access the data. But in case of OLTP, we are the users who are interacting with OLTP. So if you are buying any product, one record will be inserted in the transaction table. But in case of OLAP, no user can enter any data. So this data is coming from the transaction. So OLTP is the source for OLAP. Yeah. So OLTP, it is the place where frequently insertions and updates and deletes takes place. And OLAP, it is the place where data retrieval takes place. So it from OLTP, we will take the data to the OLAP. And as I said, any user can interact with OLTP, like e-commerce websites. Any user can interact with those e-commerce websites, and any user can control the data in the OLTP. But in case of OLTP, so after this data getting stored in analytical processing, or the data that we have, so that data we will show only to the executives, or to the business intelligence managers, or anybody who is actually want to take the data and take action on that particular data. So any user interface is a source for OLTP. Let's say, as I said, any ATM machine, or any superstore, or any e-commerce websites. So any user can interact with OLTP. And all the OLTPs are the source for OLTP. And OLTPs will always have only limited amount of data. Let's say weekly data, or it will hold only 1 day data, and then it will get stored into the OLAP. And OLAP will always have a lot of data, and this maintains the historical information. Maintains only current data.
Okay.
Yeah. So do you have any questions on OLTP and OLAP?
Yes, can you show me how is this OLTP? I understand how OLTP and OLAP works, but I don't understand where this will work.
So this is okay. These are maintained by different systems. Let's say any organization. Let's say if you take an example of healthcare. So they maintain, let's say, CRM. So that is a database where they will enter some hospital information. Let's say if you buy some MRI machine, so they will enter one record in their system. So that will get stored in one particular system. So this is a architectural procedure. So they store data in one system, and all the data, let's say in multiple hospitals, they will have this particular CRMs. So that is, I'll just show it here. So let's say hospital one has a system, and they stored daily, they are storing some 100 reports. Okay. In one system. In hospitals two, system, they are storing some daily 200 records. Okay, so all this H1, H2 systems data will get stored into some database. So this system is called as OLTP, where the transactions happen. So in a day, that transaction will get freezed, and that freezed transaction will go and get stored in this. So this becomes 300 records, OLAP. So all the data will get stored in this, and we do some ETL procedure here, which is we will extract the data from that system. This is also one system. Like this can be any Oracle, or this can be SQL, or any other Informatica, or any other database that stores data. So they maintain this system. So we do extraction, transformation, and we load into one database. And then we connect this to Tableau. And then we create visualization and publish it to Tableau server. So this is the architecture.
Okay.
So in the next day, these records will get deleted. So in H1 system, you won't see these records. And in the next day, you might have 150 records. In the next day, here you might have some 50 records. So some 50 records. So you have 200 extra. So these old records will be here only. So you will have more 200 records. So in this way, OLAP stores the data by taking the data from all these hospitals. So in the same way happens for Superstore, in the same way happens for any e-commerce websites. Same procedure.
Because more traffic is added every day, right? That's why it's increasing.
Yeah, correct. Yeah, so with that, we have covered all the topics for today. So, okay, so we are going to discuss about different types of charts, chart and graphs, and what is the significance of those charts, and what is the usage, and in what type of scenario we are going to use that particular chart. So these are the types of charts which are available. So these are the basic. So there are 24 varieties of charts which Tableau by default provides, and so there are some visualizations that we are going to discuss in this session today. So there are 8 important charts. So bar chart, line chart, and dual axis, and we have word cloud, and we have pie chart, scatter plot, histogram, tree, and heat map. So there is a significant difference between tree and a heat map. So we will discuss about all those different varieties of charts, and we are going to see what are the steps to create these variety of charts. So we have a bar chart. Basically, a bar chart is a visual tool that uses bars to compare the data among the categories. So the length of the height of the bar represents the value of the sales. So if the sales is more, the length of the bar will be more, and if the sales is less, the length of the bar will be less. So it is proportional to the if we take an example of any measure, so it is proportional to any measure. So the length of the bar will be proportional to the measure that we selected. So there are 2 types of bar charts that we have. One is horizontal and one is vertical. So the one that we are seeing right now, it is a vertical bars. So where we can the height of the bar represents the value of the measures. So now let's see how we can create that particular bar chart in the Tableau. So if you take any particular dimension or any particular measure, so one dimension and one measure are mandatory for this to create a bar chart. So now let's take an example of any dimension and any measure. So let me take subcategory, and also subcategory, and let's take sales. Yeah. So here we see all the values as a table chart. So now let's see how we can create a bar chart. So we can directly click on the bar chart over here in the show me. So there are 24 different varieties of charts which Tableau, by clicking on those particular charts, we can create all these 24 varieties of charts. And if you hover on any particular chart, it will show you what are the prerequisites of that particular chart. Venkat, can you hear us? Hello?
Yeah. Yeah.
Oh, okay. Okay, fine. So we are going to discuss about different varieties of charts today, and what is the significance of those charts and what is the importance of those charts. Okay, now let me show you how to create a bar chart here. So let's click on this bar chart so that it will create a bar chart. Yeah. So now this sorting is based on the subcategory. So it's in alphabetical order. So alphabetically, whichever comes first, it will show the bar chart. And there are multiple options where we can sort the data based on the sales or based on manual selection as well. So let me click on this sort button, so which is descending order. So it will sort based on the descending order of the value of the sales. And if I click on this ascending order, it will show the data based on the ascending order. Not only that, we can right click on it, this particular dimension and click on sort, and we can do sort based on many different ways. So these are the different ways of sorting that we can do. So sort by ascending and descending, that is one, and these are the other options that are there. So data source order. So data source order is nothing but the alphabetical order. So alphabetically also we can arrange in ascending or descending. So when I say ascending, so it's basically A to Z, and descending nothing but Z to A. It's a reverse. So we can do ascending and descending in the alphabetical order as well. And yeah, this the other one is alphabetic order. So data source order is nothing but the way the data is inserted into the table. Let's say you have inserted some 10 records into the table. So there will be an order for that particular records from 1 to 10. So in that way, so basically in the database side also it will be arranged in a particular order. It may be as alphabetical order, or it might be a so there will be some order followed by the data source as well. And the other option is alphabetic, which we have already seen. And field. Field is based on the value that we selected. So, so not only on the value that we have kept in the this workspace, we can select any other measure as well. We can select, let's say, profit. Yeah, we can select sorting based on different measure also, which is not included in the worksheet. So this is how the sorting works, and this is manual sorting. So manually, I want to keep bookcases in the starting position, tables in the third position. So likewise, I can do manual sorting as well. Or we can just click on this and put it based on the sales or whatever measure that we keep in the workspace. So that is how we create a bar chart. So we can also call this as a bar diagram or bar chart. And the important thing to know, it depends on the how long the bar is. So it is directly proportional to the value of the measure. And The one which we are seeing in this particular Tableau is it's a horizontal bars, and we can change it to a vertical bars as well. So if you do click on this swap rows and columns, so from horizontal bars to it will become a vertical bar. So let me click on this. Yeah. So what happens here is subcategory which was in rows moved to columns, and with measure which is in columns shifted to rows. So it is swapping from whatever is there in columns will be moved to rows, whatever is there in rows will be moved to columns. So in that way, if you do, horizontal bars will become vertical bars. So the representation is same, but it's the way that you want to represent in your dashboard. So if you have one sheet which is of vertical bars in a dashboard, so you have to keep the other charts also in a vertical format. So you need to be consistent across the dashboard. If you are using horizontal bars in one particular dashboard, so in other dashboards also you need to use horizontal bars itself. So that is about bar chart. So it is used to compare the values of several items in a group at a given point in time. So here we can directly see the data, and we can analyze and say which is the value, or which is the category which has the highest amount of sales and which has the lowest amount of sales. So we can just see and identify that particular subcategory. So we can also put this subcategory into color, so that each and every subcategory has a different color. So as uh, as a human, we can remember the colors and the visualization. So we can identify whichever has the highest value. So we can identify that particular. Let's say chase has a green color. So if it goes down in the next month, so the sale amount of that particular chase, if it goes down to the next level down, so by remembering that color, we can identify that particular chase has that particular sales has gone down. So with the bar chart, we can identify each and every sale amount, and based on the length of the bar, we can identify the value of the measure. So that is about bar chart. And so line graph. Line graph is commonly used to display change over time. So basically, whenever we have date, whenever we are using this date dimension, then we make use of this line chart. So the main usage of line chart to represent the change over time. So the how the measured values getting changed uh, across the time. If you want to show that particular thing, we need to show use this line chart. So this is also like a trend chart. So we are showing the trend, how it was there in the previous years or previous months, and how my sales is performing in this particular current month. So to identify that, we use this line chart, and it is connected by straight line by two axes. So so it will also between two set of values. So let me just create one particular line graph to understand it more better. So to create a line chart, so we need to have a date dimension. So that's a mandatory prerequisite for to create a line chart. So I'm just taking order date. So and I'll take month of order date. Yeah, and I'll take sales into workspace. Yeah. So if I take directly, so it will directly show me the line chart. So it's by default, Tableau will automatically create a line chart. So whenever there is a date dimension and when any particular measure that we use, so Tableau will automatically create a line chart. And by seeing this particular chart, we can say our sales amount is trending up. So from 2017 to 2021, so we can identify that our trend is going up, and we can also put some trend lines. So if I click on show trend lines, so my trend is towards upside. So from this amount, $14,237 to, so the last amount which I have right now in 2021 or December 2020, I have $83,829. So that is how my trend has gone towards to that amount. So if I show this trend, so that means I'm going towards the upwards itself. So my sales is performing good. Sometimes it has gone down, but there is a spike after that downwards. So with the line chart, we can identify how I'm trending up or trending down. So line chart or line graph is a type of chart which displays information as a series of data points. So anything in the let's say this is a point. So all these are data points. So let's say we have 48 marks in this particular chart that we have created. So when I say 48 marks, so this particular one which I'm highlighting or hovering on, so that is 1 mark. Likewise, I have 48 marks. So let's say I have 1, 2, 3, 4. I have 4 years of data, which is in each year I will have 12 months. So which is 12 into 4, 48. 48 months data that I'm showing here. So that is what is data points. So I'm currently showing 48 data points in this particular chart. So if I go to sheet 23, I have 17 categories, 17 subcategories, and I'm showing 17 subcategories sales amount. So that is nothing but 17 marks. And I can also call it as 17 data points. Okay. So in case of line chart, we call it as a series of data points. And why do we call it as a series of data points? We are showing one after the other. Like after January, we are showing February, March, April. So these are like a series of data points or a series of amounts sales that we are showcasing. So these are the basic charts that we are discussing, like bar chart, line chart, and other tree map, and all these are basic fundamental charts that we draw. Okay, so we also have a dual axis chart, which is a combination of not only line and bar, it is a combination of two different things. We can take two multiple, let's say 2 line charts and 2 bar charts. We can take any particular chart, or we can take 1 circle chart, 1 pie chart. We can combine all this together and make it as a dual axis charts. So now let's see how we can create a dual axis chart. And before going to that dual axis chart, I will just show you on how to keep labels on top of this particular lines. I can click on this. So let me creep profit as well here. Okay, so these are two different charts that we have. So let me remove these trend lines. So I'm just removing these trend lines. Okay, so I have two different axes. So this is one axis for sales, and this is one axis for profit. So I'll just click on this and make this as a dual axis. So when I do dual axis, that means both the axes will become one. Okay, so I have one axis this side, and I have another axis this side. So I can do a synchronous axis. So when I do synchronous axis, this axis and this axis will become same. I'll just do Control Z. Okay, so now if you see, so this is profit and this is sales. These axes are not same. Here it starts with 20K, 0 to 20K, and here we have 0 to 5K, 10K, like this. And when I do synchronize axis, both will become 1, 0 to 20k, 0 to 20k. Like that it will start. And we can remove one axis. Sorry. We can remove one axis by clicking on the unchecking the show header. That is one. And I can make one as bar. Yeah. So this is a dual axis charts. So we can make one as a bar chart, line chart, or we can make different we can select from these charts. And I can make it as a circle chart or shapes. So likewise, I can do different varieties of charts. I can make it as a area map like this. So this is about dual axis chart and word cloud. So this is some in general we don't use this word cloud. Why? Because this is not in a proper uh, organizational standards. So it is just for fun, or we can some organization might use this particular kind of workflow charts. So now let's see how we can create this workflow. So to create workflow, we just need any dimension. Let's take subcategory. Let's put this in text and make this as, and also put this subcategory, or let's say put sales. So based on the sales amount, we need to have this word size. So I will need to put this as a text, and I'll put subcategory in a color. Okay, so the size of the subcategory name is dependent on the value of the sales. So here, if you see the fasteners, it has a value of $3,024, and if you see phones, it has $330,000. So according to the size, according to the value of the sales, so the size of the names will be there. So it is proportional to the size of the names. So if you keep that sales amount to the size, so that's how we can create a word cloud chart. And now let's see a pie chart. So pie charts are generally used to show the percentage or proportional data. So when you want to compare between particular regions, or you want to show some categories, so then we go for this particular pie chart. Let's say if you have a percentage, in case of if we take an example of marks percentage that we get. So in an overall, we'll get 100 percentage. So to get 100 percentage, we need to get 6 subjects score. So after comparing all those 6 subjects only, we'll get 100% altogether. So that 100%, so you will get 20% in one subject and 30% altogether combined to will get us 100%. And now let's see how we can create this pie chart. So to create a pie chart, we need, let's say we have a region column here. Let me drag this region. Okay, we have 4 regions, and I want to show sales amount, and I'll put this as a pie chart. So pie chart will be automatically enabled. So one or more dimension or 1 or 2 measures are needed to create a pie chart. So if I just click on that, I can see the pie chart. So here are the values, and I just want to show, so all this together will be some amount, let's say sales. So this is our 100% of sales. Okay. So 2297201. So to get this amount, we need to get some amount from here, some amount from central region, some amount from west region. So we can do a percent of total so that we can see the exact values or the percentage of contribution by each and every region. To see that, you can just put on this and click on quick table calculation and click on percent of total. Okay, so we can directly see and identify. So 31.58%. So the contribution is more from west side. So that thing we can identify by creating the pie chart itself. So the percentage of contribution is more from west and east. So that we can identify by easily be identified by using pie chart. And we also have seen how to create a donut chart as well. So let me just show you. So after creating this donut chart, we'll wrap up this session. So this is how we can put this. So this is just a workaround on how to create a donut chart. So we need to create two pies basically. So one pie we need to make it as blank. So I'm just making one pie as blank. So there will be two options that are available. So one is for this pie and the other one is for this one. So I have removed that and I'll make that combine these two by doing a dual axis. And I'll adjust this size. Yeah, and then make the color as white. So this is how I can make a donut chart. I'll increase the size of this one. Let me just reduce a little. Yeah. Yeah. So this is how I can create a donut chart from a pie chart. And go to format and remove those extra lines which are there, zero lines and all. You can remove. And let's go to other one. Lines. Yeah. So this is how we can create a donut chart and remove the headers. Okay. Yeah, Vincent. Any questions from the charts that we have created?
No. Sir.
Okay, so in the next session, we'll complete all these other charts and we can go on to the next 18 session.
Yeah.
Okay.
Yeah.
So scatter plot. So basically, scatter plot will show the relationship between two different variables. So in the chart that you see over here, we have sales in the x-axis and we have profit in the y-axis. So we can able to correlate with two different measures or two different variables. So and also we can this is we can call this scatter plot also a correlation chart, and so scatter plots are useful to identify or to understand the relationship between two variables. So yeah, so we can identify from the, let's say for profit we can identify from top to bottom. For sales we can identify from the left to right. So now let's see how we can create this scatter plot. So I'm just opening Tableau. Yeah. So I'll take an example of one sales. and on profit. And I'll take some region. Okay, one has to be in the columns and one other one has to be in the rows. Why? Because we need to get one measure as profit, I mean, one measure as y-axis, one measure as x-axis. So that is the reason, and we'll put region in the color. So this particular one circle will get divided into 4 parts. Now let's see. Yeah, and now we could see uh, west region. So it has a high amount of sales and it has high amount of profit. So with this we can directly say when there is more sales, there is more profit. And in case of this one, so this has less sales but more profit. And this one has less profit and more sales. So with this we can identify which is having more, and so we can correlate between two different categories or two different variables. So when the sales is moving towards upwards, profit should go towards right. So then that means both are in a correlation. And if you see in the case of these two categories, when the sales is or profit is going towards the right, the sales is still there itself. And in the case of this one, say profit is less, but sales is more. But in case of these two regions, west and east, both are like the same way. Like towards up it is 700k and towards right it is 100k. So if you see the graph, so it is like normal. So from top to bottom, you have some distance. From left to right, you should also have the same distance, so that you can say that the trend is going towards it is say when the sales is proportional to the profit. So in this case, we can say the sales is proportional to the profit. But in case of these two uh, regions, we can say sales is not proportional to the profit. So having said that, so if the sales is more, we can't say we will get more profit. It depends on the cost of that particular product. So that is how we can uh, correlate between one measure and the other measure. And histogram chart. And this is one of the most important chart that we have ever seen. So we have discussed about this particular chart while we are creating the bins in the chart. So Venkat, can you tell me, so can we write bins on dimension? I mean, can we create a bin on a dimension?
Yeah, hello? Yeah, sorry.
Yeah, Venkat, can we create, is it possible to create a bin on a dimension?
Bins on, no, we need to create measures, right? Because if it is only
Correct. We can create only bins on measures only.
Yeah, by converting into measures we can.
Yeah. So groups we can do on both dimensions and measures, but bins we can do only on measures itself. So now let's see how we can create a histogram chart. So before creating, we have discussed this before, but as this is an important chart, I'm discussing it over again. So let's see the sales. Yeah. So this is the amount of sales that is there. So let me sort it down. Yeah, it is starting from $1, and so the minimum value is $1, and the maximum value is $22,638. So I have these many values, and I want to bucketize to $500. Like from 0 to 500, how many customers are there? And 500 to 1,000, how many customers are there? So I want to identify those number of customers, and I want to see in that bucket how many number of customers are purchasing the more number of sales. So let's see. So I'll just create sales, create bids. So Tableau will automatically show you the minimum value, which is 0, and the maximum value, which is 22,638, and it is suggesting us the size also. So 447 is the suggested size by the Tableau. So we can make it as a 500. So bin for sales. Okay, and I'll just put sales first, and I'll show you how this is working. Bin for sales. Okay, and let me do a. So basically, what it is doing is from 0 to $499. It is summarizing the sales amount. But let me just do a. So if I remove this aggregate, so then it will not do the aggregation. So it will not do the aggregation, and it will show us the values itself. So let me just. Yeah. So 0. So this is the bin that we have created. So this will hold values from 0 to 499, and this will hold values from 500 to 999. So if you see, so these are the values which it holds, and this has many. So let me just put it over here and make this as discrete. Yeah. So it will have 0 to 499 values. Let me just drag it down. So this is without aggregation. Yeah. So till 499.99, so we have created a bucket. So again, from 500 to 1,000, there is one more bucket. So now let's see how many customers are there for each and every bucket. So now let me just put customer name. I want to see the count. So to see the count, I just need to put go to measure and select count. So that is the aggregation that we can do. And let's click on this bar chart. Yeah, I'll just do a swap. So if you see, there are customers who made 0 to $499 of sales. Let me just put this count of customer here. I need to make this as continuous. And let me just put customer name and make this as count. Yeah. Okay. So we are not getting this because we have removed this aggregate measures. So let's just click on this aggregate measures. Okay. So then we could see, so this is not doing the aggregation basically. So when we select this one, so it is showing us the each and every customer individually. So it is not counting from 0 to this value, like this is not counting the number of customers. So to do the aggregation, what we need to do is we need to click on this aggregation option. So until unless we do, so that will be by default that will be selected. So depending on the requirement, we might we might do uncheck for that particular aggregate measures. So this is how we can create a histogram chart. Any doubts, Blanket, in this chat?
No, sir.
Okay. Yeah, and also we have a tree map. So there are two different charts which we have. One is tree map and a heat map. So most of the time we have this interview question as what is the difference between a tree map and a heat map. So let's talk about a tree map and heat map separately. Then I will tell you the difference between the two charts. So yeah, so tree map, the representation of tree map is basically based on the color and based on the size of the box and hierarchical arrangement of the items. So let's say if we have a value or if you have the sales amount is more, then the color and thickness of that particular item will be thickness in color, and if the value is less, that will be in the lighter in color. And if the so value is proportional to the thickness of the color, and value is proportional to the size of the box. If the value is more, so the size will be more, and also it is hierarchically arranged. So from left to right. So whichever has the highest value will be on the left top, and whichever has the lowest value will be on the right bottom. So with that also we can identify that this particular item or that particular product is having high or low value. By seeing that particular tree map, we can understand. So now let's see. So to create a hierarchical or tree map, so one dimension and one measure are mandatory. So those are the prerequisites for that tree map. So let me take a subcategory, and let me also take sales. And click on show me. Click on this tree map. Yeah. And let me show the values on top of this. Yeah. So if the value is more, so that will be on the left top corner, and if the value is less, that will be on the right bottom corner. And so based on the size and based on the thickness of the color, so we can identify whether the value is more or less. So so there are three ways of representation according to the hierarchy, according to the thickness of color, according to the size. So that this is about tree map. And now let's talk about heat map. So heat map is nothing but, so there are some similarities between a tree map and a heat map. So it is also based on the color, and it is also based on the size of the box or size of the circle, whatever uh, graph that we use. So these two are similar, and the one that is missing is hierarchical. So we don't have any kind of hierarchy in this particular heat map. So that is the main difference between a tree map and a heat map. So now let's create a heat map. So let's take sales, and let's take state. Okay, and let me click on. Let me click on this. Or I can do this one as well. So basically, this can be called as a heat map. So heat map in the name only it defines that. So depending on the heat. So here heat means nothing but thickness of the color. So based on the thickness of the color, we can say that the value is more. And if you see, there are 2 or 3. So United States, California. So California is the highest value. So 45688. So here we can see this is called as a color legend. So minimum value is 920 and the maximum value is $457,688. So depending on the value, if it is near to this maximum value, then it will be in the thickness in color. And if it is near to this minimum value 920, then it will be in lighter in color. So with that we can identify. So mostly it is based on thickness of the color. And there is one more type of heat map where we can do based on the size also. So let me just show you the other one. So we can click on this other chart, and here we can see the size itself. Okay, based on the size, we can identify which state has the highest value. And if I want to see based on the color also, I'll put this control select this sales and put it on the color box and see I can identify based on the thickness of the color also. As the lighter ones are not appearing, so I will use a different pattern to see the difference. So I'll just use something like this, red, green, white diverging. Say apply. Okay, yeah. So minimum, whichever has the minimum value will be in the red in color, and between there is something like you see this is, so it is like in between, so that will be in lighter color, and whichever is closer to the maximum value that will be in green in color. So we can change the pattern also. We just double click on this and there are some patterns available here, and there we can select. That is about the heat map. And the main difference between a heat map and a tree map is hierarchy. Okay, so that is about all the different charts, and yeah, difference between tree map versus heat map is hierarchy. And the similarities of measure value is proportional to the size and thickness, color thickness. Okay, so that is about 17th session. So if you have any questions, then we'll go for the questions, and then later we can go for the 18th session.
Yeah. Yeah, no questions, sir. Go to 17.
Oh, yeah, and we'll start our 18th session. Okay. Okay, so in our 18th session, we are going to discuss about how to format our workbook. So in Tableau or any reporting tool, so while we create some technicalities or while we create some high-end different types of charts, it is also very important on how you are presenting in the dashboard. So we need to format our dashboard in such a way that it looks good. So formatting plays a vital role in any reporting. So this today's session is completely about how to format our workbook. So these are our topics. So how to format at sheet level, and how to format at workbook level, and the worksheet level, and there are some text and numbers, tables, cells, table structures, and there are some custom color palettes that we create. So these are the so all these topics will cover on how to format the data uh, to represent in a good way. Okay. So formatting is an important part of both our analysis and presentation. So you can almost format everything you see on the worksheet, including the fonts. So there are like 5 options which are available, which we can do: fonts, shading, alignment, borders, and graph lines. So these are the 5 options that we can do. So with this, it will cover everything. So if we do all these 5 options, so we can make a good presentation. For example, in a text table, you may want to add banded shading to help you visually separate consecutive group of rows or columns. So we can do that. So let me just start building some dashboards or worksheets. So let me just start with some table charts. So I'll put sales, and I'll put product. I'll say, okay. So now these are my products and all. To see all everything fit with. Okay, I can see the complete names, or I can just do a drag over here. So this alignment is also comes under formatting. Okay, so first let's talk about at workbook level. So you can click on this dashboard, or let's just click on dashboard and click on format. So this is at the workbook level. So if you apply it here, so the changes will happen all over the worksheet. So let's say we have 33 different sheets in this particular dashboard. So if we make change over here, so everything will get changed in the dashboard. So now let's say I'm putting this dashboard shading as this one. Okay, so this is the dashboard shading, and so this is the dashboard shading for this particular dashboard. And click on this format again. Okay, and also put this as say 28, or let's just put some sheets on this to understand it more better. So I'm putting some sheets. So there one is cost table, one is pie chart, one is heat map, and the other one is histogram chart. See, wherever it is getting highlighted, I can put it over there. So if I want to be on the entire sheet, I can put it like this, but I want it on the side of this particular cross table. I'll put it over here. So this is how the arrangement happens. Okay, and Okay, so these are the sheets that are there, and now I want to do a format. I do a format, and I want to show and make it as bold. So this is about dashboard title. Okay, so we don't put that dashboard title here. So let's put title. So to show title, you can click on this dashboard title also. So show dashboard title. So this title is nothing but the name of this particular tab. So whatever name that we write here, that comes as a tab order. So with that we can change the title. So whatever font that I change here, that will change over there. Yeah. So I'll keep it as 18. Okay, and I can put some shading or background color for that particular. Yeah. So I can change the color. So this is how I can put some background colors, and I can do a left align or a center line, something like this. I can put a border as well, and I can select the thickness of the border. So these are the options that are there, and worksheet titles. So if you see, each and every sheet has a title: heat map, cost table, histogram chart. So I can change from here itself. I can make those worksheet titles as bold. I can make italic, or I can make underline. So these are the changes that I can do. And if I want, I can put some different color as a background color. If it is not, yeah, I can put some, yeah. So these are the colors that I can change it over. So while creating any particular dashboard, so we need to use the lighter colors. So, so our worksheet or our work has to be getting highlighted, not the background color. So whenever we choose anything on a dashboard background or a worksheet background, so that color has to be light in color. So that is the reason if you see the Tableau provided colors, if you see that will be in a lighter colors only. Or we can choose any color that we want. And we can put some hexa code also, and we can put RGB as well, or we can directly pick from the screen color. So that is the option. Those are the options available, and we can align the sheet titles as well. And so text objects. So these are the okay. Let's say when I say text objects, so this is the text object that we can put it over. Text. This is the text object, and we can go to format, dashboard format, and we can change it over here. So if I want to put thickness, I can put thickness for that. Yeah. So this is how we can make the changes. So now let's just see the one chart which is already there. So now let's see this world indicators chart, how the formatting is being done. So let's set that open. Okay, so this is the world indicators chart. Okay, so this is the world indicators chart that we have. And now let's see some dashboards. Okay, so if you see the dashboard, so this is the, so if you see the background color, so that is white. So we can take any lighter color, or any we can directly take white color. So that is preferable. And yeah, so let's see how the formatting is been done. Yeah. So default color that I have selected is white color. And so title font is 18 and they have left aligned it. And so they have not used any borders and they have not used any kind of colors. So they just selected none. So none means there is no background color on that. And for text objects, they have used 9 point and left align. And we also have these worksheet titles. So for dashboard title, they have kept size of 18. And worksheet titles, they have used a size of 15. So that is how we can do the dashboard design. So now let's see how we can make use of the formatting options. So that is at workbook level. And yeah, so we also have themes available, normal themes that are there. So now let's see how we can select those themes. So let's just go to this worksheet. And let's go to the scales pane. Okay, so this is one format which is there, Tableau has already created. And now let's go to, okay. So these are the some themes that are there. So default Tableau will show you Tableau book 9 point size. So this is the default size, default format, and default font that they provide. And so these are the workbook themes that are there. So now let's click on previous. Okay, so previously it was in this format. So if you see, this font is getting changed and this alignment is getting changed and everything will change, the size, the percentage, everything. So it will be in a certain theme and I can change. So you observe this particular font and everything. So if we go here and click on this, click on modern, the format is getting changed. If I do a control Z, so this is how the representation is. Here we have title and which countries spend more than 14% of GDP. And if I do a control Y, okay, so this particular title has been central line and the names have been changed everything. So it is an Arial. And now let's go to workbook theme and click on classic. Okay, in classic we have this borders and all. And if you see, this workspace is using more borders, thick borders. And if you see, the font is also changed from Arial to COG. So that is, these are the default themes which are there, which we can use. And now let's go to next slide. Okay. Now let's see how we can do formatting at worksheet level. So to format at worksheet level, so there are 5 different options that are available. So let's go to format. Okay. So these are the 5 options: font, alignment, shading, borders, and lines. Font is nothing but it will, we can select Arial or any Sigoi and Tableau fonts that are available. And alignment is, you can align it as center line or left or right, that we can align. Shading is nothing but the color, background color that we can select. And borders, so the borders that we see over here, the thickest borders, the black, which are in black in color. So there will be borders for every particular aspect. So we'll see where we can see all the borders. And there are some lines. So we have 0 lines, we have trend lines. So there are some lines which are defined in Tableau. So we'll see all those. So now let's just click on this font. Okay, so here also we can see those 5 options. So now this is specifically about font. And if you want to switch to alignment, you can click on this one. And if you want to switch to shading, this is the option. So likewise, we can go for borders and lines. So now let's see. Okay, so this is for the entire sheet, and instead of entire sheet, you can, if you want to do only for rows like this, that we can do, or only for columns like this, if you want to do, we can do. So if we do it for worksheet, so that will be for both rows and columns. So now let's see for worksheet. So I'll just click on bold. Okay, so if I do bold here in the worksheet, so that is becoming bold for the entire sheet. And this title is different. So this title comes under different one. So this we can do a format by just right clicking on this. So we can do a format. So there also we'll have the color, font, and the background color that we can change. Okay. So if we do a worksheet level change, that will happen for both rows and columns. But let's say, and we have talked about pane. So pane is nothing but this particular space is called as a pane, and the entire thing is called as a table. So if I do only for pane, this only this will get highlighted. So let me just show the values on top of this bars. Yeah, and I'll make this as bold. Yeah. So what is happening is, so inside this pane only, this is getting affected. And if I do at a worksheet level, so worksheet is nothing but only the headers will get highlighted. Okay, and if I want to do only specifically inside the pane, then I will go for this one. And header is also same. So these two are called as headers. So if you want to color only those two, then we go for that. And so the next option is tooltip. So here we have a tooltip option. So when we hover on any particular bar or any particular data point, so we will be able to see the tooltip. And click on this bold and see on this. So when you bold that particular tooltip, so we can see inside that tooltip everything is getting bold. And we can change the title also. See, we can change the font of title as well. So this is how we can make the design. So this design is irresponsible of any like you shouldn't be using like this particular font or this one. So it depends on organization to organization and developer to developer. The design will be different. And in some organizations, they will give you certain standards on how to use the font color and thickness and how to use the borders. So that will be defined by the organization or depends on the client requirement. We use this particular design. Some users want to see the borders, some users doesn't want to see the borders and all. They just want a report like simple report like this, like without any borders, without any highlighting the text and everything. So they want to just see the normal without any highlighting the background and everything. So they just want to see the simple report. So that is how we can do the formatting. So now let's talk more about other options. On global indicators, business. Okay. So we'll talk about this one. So if you see this, each and every measure, like we have 3-4 different measures over here. Each and everything is color conditioned over here, and depending on the value, this color is defined. And now let's see how we can change. And we also have a grand total here. So at the bottom we will have some grand total. So let's click on this. If you want to show the grand totals, show the column grand totals. Analysis, totals, show columns to analysis. Okay, let me just show you how to show the totals. So let's take region and some measure the number of reports. So to do a total, we need to go to analysis and to column grand totals. Yeah. So this is how we can make a total. And now let's see how we can do the formatting. Okay. So these are the options. So this will be similar for all the for, let's say, for alignment, for shading. So everything will be similar. So now let's talk about the rows. So for rows, if I want to do the header in a different color, so only the rows are getting highlighted. Yeah. So this is about, if we go to this one, I want to highlight only the total one. So if I click on this, this is the grand total. If I want to do a italic, so this is getting italic. This value is getting italic. So this is about pane. We have done on pane. And if I want to do this particular one as a bold or anything, so this is the header. So I can do it as a bold or underline. Yeah. So we can make a differentiation. So this, all these are regions, and this is a grand total. So we can make a differentiation between all those regions and everything. And that is about rows and columns. Now let's see. So nothing is getting colored. Why? Because we don't have anything on columns. So let's put some column on. Okay. Let's take something. Okay, let's take here only. We will be having something on the column side also. So click on format, click on font. Okay. So I'll just click on bold here. Okay. So now the columns are getting highlighted. So when you do rows, so click on this board. So only rows are getting highlighted. So this is the separate thing for rows and columns. So whatever is in rows will get formatted in this one, and whatever is in rows will get formatted in this one. So region is there in rows, so region is getting colored, or region we are changing the font and everything. And in columns also we have different year column over there. So if you want to change the font for that particular column, then we go for this particular columns column. So that is about font. So for each and every font we can do all these options. And if you see font, we can go from 8 to 72. This is the maximum available. And we can do bold, italic, and underline. And the color of the font we can choose from the hexa code as well, or we can pick from any particular screen color. So we'll get a thing like this, and we can select. Let's say I want to take this particular color. See, this color also I can pick. Like this, I can get color from any thing on the screen. Yeah. If I change for worksheet, it will be for entire worksheet. So that is how I can make the changes for font. And likewise for similarly for alignment as well. So for alignment, we have these options. So we can put it on automatic. So according to the size, according to the space available, it will take the automatic. I mean, automatically it will arrange the center aligned or left aligned or anything. So if I want to align it on the center and the bottom. So this is about bottom, and here also we'll have center and top. If you see this is moving. Whatever is there in the pane is moving. Okay, and we can rotate the categories. I mean, these values also like this. Sometimes we want to show uh, slant. Sometimes we want to show this side. So if you want to show something different, or something is aligned, or if you want to show upwards down or downwards up, we can use this particular option. And wrap we can use sometimes. Let's say this Americas is there and it is not visible. So what happens when we do wrap? We'll just do a format, click on alignment and click on. And when I do on, so I'll just move it slightly down. Okay, so what is happening is I'll just see the text without disturbance. So I'll just see the entire text when I'm wrapping that particular region. So that is how I can make. And while doing the format, I no need to go every time here and do the formatting. I can just right click on any particular thing. Let's say if I want to do a formatting for this thing. So I can just click on format and change the formatting. See, but it will change for everything. So this thing is coming under the pane. So whatever is there, so if it is related to the other data points, so if you change for one data point, it will affect for other also. And let's say if you are doing for grand total, okay, if I am doing for grand total, so grand total is here. I want to make grand total as italic and underline. Okay, so this is how I can make the change based on the selection. So I can just right click and select the values and do the changes. So click on format. So I will get specifically for that particular number. The number of records are the values that are available here. So I'll just I want to rotate. Okay, I can do all this by just doing the right click also. So to understand this formatting, you need to practice on this thing, and you need to understand what is happening, which option is correct for which one. So let's say, so when I'm making this change, you need to understand what is happening in the entire dashboard. When I'm making italic, so everything is becoming italic. So you need to understand what is the change that is happening in the worksheet. So you need to go one by one with all these 5 different things and see how we can make these changes. So now let's see format, shading. So now let's talk about this shading. So shading is basically the background color of the worksheet. And so this is the background color of the worksheet. But inside the pane, if you want to color, so this is the pane option that is there. So inside the pane, we can change the color. Or I want to put only white color. Yeah. So this is the way that I can make some changes in the background color of the worksheet. And also this is the grand total, right? So if I want to make changes, so this thing is called as paint, and this one is the header, which is the region column. So for grand total, I want to show in a thicker color. Yeah, like this. And header, I want to show some lighter color like this. So the changes will happen like this. So let's talk about the types of table calculations. So these are the list of table calculations that are available: running total, difference, and percentage difference. So these are the list of table calculations. So we will go one by one. Okay, so I'm selecting the sample superstore database, and I put profit, profit data, and I take date, order date, and I'll make this as month and year. And I just want to show the numbers. Yeah, so here I'm showing monthly, month and year wise data. So here I could see all the information of profit by monthly. So this is normal profit that we are seeing, which is sum of profit. So which is aggregating to that month level, and it is giving us the information. And I'll create a duplicate profit, and in that we'll compare how table calculation works, and we can see the difference between normal sum of profit and the table calculation. So I'm just making this duplicate. So this is our duplicate. Let me click on this. Oh. So I'll just rename this profit copy as profit table calc. Okay. So these are the normal values. So I just duplicated the existing profit. So now we'll see one by one. So to see table calculations, we need to right click on each and every measure value. So here we could see to create quick table calculations, and this is one more option to add table calculation. So now we'll just click on this quick table calculation and click on running total. Okay, so it will calculate the running total. So as it depicts in the name, so we can see the value is getting added to the next number. So if you see the difference between the normal profit and the running total, so the first value will be same as it is, and the next value will add it to the February, which is the running total, and so January plus February gives you the February value, which is 3312. So it will add till the end. So at the end, you will have the total amount, which is 286397. And we can also edit this particular table calculation by clicking on the edit table calculation. Yeah. So we can do the running total by aggregation functions. So these are the aggregation functions that we can use. One is sum, average, max, min. So by default, Tableau will automatically do the sum aggregation, and if needed, we can change it to other aggregations. So let me change the above one also. So if I change the above one to let's say average. So it will show you the average value. And now let's edit this table calculation and make this also an average. And make here also an average. So what is it doing is it will do the average, and let's say it will add up this to 31 plus 18.7 and divide by 2. So it will sum up the all the items and divide by the number of items. So that way we can get the average. So I'm just doing Control Z to remove all the functionalities. So that's how we can create a running total. And let's go to difference. Okay. So difference we can calculate it based on the previous value. So it will calculate the value with the previous. So as we don't have any value before January 2017, so it will not show you anything. So there is nothing to compare with any number. So in that case, it will show you null. And in case of February 2017, what is it doing is it will compare the number with the previous month, and it will give you the difference. And same goes for March 2017. It will compare with the previous month. And we can change the comparison and how it can be done. So by default, it is related to previous value. So and we can change it to other things. So basically, the previous value is nothing but the previous month, and it will calculate the difference. And in case of relative to, so the next value, in case of the next value, it will compare the next one, and it will give you the difference. And when you click on the first, so it will compare every time with the first value. So if I'm comparing January 2017 with January 2017, it gives a difference which is 0 always. And in case of February 2017, again it will compare with the first value, which is January 2017. So all the month values will be compared with the first value, which is January 2017 in this case. And we can change the relative to last, and it will compare with the last number, which is December 2020. December 2020, and it will compare every time with the last number, which is December 2020. And this will be, and each and every month, every time it will compare to December 2020, and it will show you the value of, this will show yeah, so we can compare, so every value will get compared with the last value of the this particular month. Okay, are you back? Hello?
Sagar, actually, I'm here and please continue because I'm getting a lot of sound from my AC.
Okay, no problem. Yeah, I'll continue.
Yeah, I'm hearing through my headphones. So I came outside right now to talk to you.
Okay, sure. Yeah, I'll continue. Okay, so we can. So this will compare every time with the last value, and so relative to we can change in the 4 ways, which is previous, next, first, and last, and we can change the compute using as well. So we will talk about this table across and table down in the in this session itself. So this is about running total, and now let's talk about percentage difference. So it is also similar to the difference, and but it will calculate the percentage difference when while comparing with the previous value. So here also we will have 4 options. Likewise, for the difference, we'll have 4 options for this as well, which is previous, next, first, and last. And I'll show you how we can create the percentage. And the same goes for the first value. So when there is nothing to compare, so it will show you null. Why? Because you're comparing with something which is not there. So when we are comparing which is not there, then it will show you null. In case of so it's mathematical also. When you are comparing anything with null, you will get null as a result. So in this case also, what's happening is, so we are comparing with a value which is not there. So that is why we are getting the answer as null here. And in case of February 2017, so it is the minus 64.81 percentage downwards when compared to the January 2017. So there is a reduction of 64.81 percentage of profit when compared with the previous month. So now let's calculate on how to get the percentage difference. So this month minus previous month 2450 divided by previous month, which is your 64.81. So that means there is a fall down of 64.81 percentage, and same goes for all the months. So every time it will compare with the previous month, 499 minus 862 divided by 862. So in this way we will get the information of all the details till the end. So every time it will compare with the previous value itself. And this comparison we can change by using relative to next, previous, first, and last. And now let's talk about percent of total. Okay. So when I say percent of total, so it will every time it will take the total amount and 2450, which is our current January value, and I will show you how to put total. So we need to click on analysis and click on totals and click on show row grand totals. So we could see a grand total here. $286,937 divided by, sorry, we need to 2450 divided by 286,937. So it is the current value divided by the total value. So there you will get the percentage, and we need to do into 100, which is 0.86 percentage. So this way we can find out the percent of total for each and every month. Tableau will automatically write some calculation for this. So instead of, let me show you that calculation. So we are just right clicking and selecting that particular information, but inside this Tableau will write an calculation. So what is it doing is it will do the sum of profit, which is the exact value of this one. It's a 2450 and divided by total, which is 286937, which is a grand total. So if we do that, we will get the percent of total for that particular month. And here also we can change the comparison. And we can do the compute using, if you want to do the table across or table down or based on the order date. And if you want to do based on years also we can do. So for that what we need to do is we need to put order date. So what is it doing currently is it is doing for all the years and all the months. But if you want to do percent of total only till the year, so we need to put year of order date here and edit the table calculation. Edit the table calculation and select a specific dimension and select the month of order date, year of order date, and select the year of order date. And we can select the custom and select a category. Let's put only year of order date. Yeah. So with this we can calculate the percent of total over here. Yeah. And we can select quick table calculation and edit the table calculation and remove this year of order date and select this one, year of order date, and make this as discrete. And put it before the month of order date. Yeah. So in this way we can see the year-wise monthly details for each and every percent of total. And let's go back to the PPT over here. Okay. So running total basically it aggregates the data from first level to the last level. So it can do this by summing up values, averaging the values, and replacing all values with either the lowest or highest actual value. So running total doesn't have to be sum. So we have seen there are 4 types of aggregation functions which are available for table calculations. There are 4 types, like we can do sum, average, min, and max. So sum basically what it does is each value is added to the previous value every time. So running total basically in the name itself it is mentioned that it is a running total. So whether it might be a date column or whether it might be a dimensional name column or any category column, even if it is any dimension column, we can add the value of the previous value. So it will go till the end till we get the total. And in case of average, what happens is, so the running total averages the current and all previous values. So it will do a sum of 2 values and divided by the number of contents. And minimum how it works is all values are replaced with the lowest value in the original partition. So it will compare the two values and it will show you the lowest value. So let's go back to the running total and compute using and let it table calculation. And let's make this as maximum. So it will compare every time, it will compare with the previous value. Let's select the running total. Yeah, sorry for the inconvenience. So we can do the max and min over there, and so let's do this for difference, and let's make this as max. 1 second. So we need to make this as maximum first of all. Compute using maximum. Yeah, so it will compare both the values and it will show the maximum value over there. So let's choose automatic. And now let's go back to the PPT. So there we can see the all values which are replaced with the highest value in the original partition. And how to add the secondary calculation. So we can also add, so there is one calculation that we have added right now, which is a primary calculation, a primary table calculation. And with running total and moving calculation, we have an option to transform the values twice. Like we can, so if you do a running total, we are doing one transformation, and if you are doing another table calculation on top of that, so that will be another table calculation, and so that is called as the secondary table calculation. So now let's see how we can do a secondary calculation. So let me remove this profit copy and let me put profit copy. Yeah, and let me make one more copy of this one, duplicate. So I'll put this. So I will do primary calculation in the profit copy. So I'll just do a running total. So all the values will be same before I do anything. So all the values will be same, and right click on this and click on quick table calculation and click on running total. So here I have applied the running total calculation, which will show us the running total. So that is the primary calculation where it has applied the one primary calculation type. And in the secondary calculation, what we will do is we will do a difference one. So what it does is it will calculate the difference from the previous value, or we can select the list of values where we have seen previous, next, and first and last. So these are the four options which we can do based on the relative to option. So relative to or comparison with comparison with previous, next, first, last. And now let's do a primary calculation for the third one, which is running total.
Yes, sir.
Yeah, Venkat, you are back?
Yeah, no. I'm listening what you are saying, but I just put it in a hold because I'm getting a lot of disturbance from the other side.
Okay. Yeah, no problem.
Yeah, I'll put it in a mute. Okay.
Yeah, sure. So I have applied the primary table calculation. Now I'm going to apply the secondary one. So just click on this add secondary calculation option. So if I click on this, I will get this pop-up get extended. And yeah. So here what it will do is it is doing difference between this February month and it will do a subtraction with the January month. So it will do for all the months. So here also we have this option related to compare with the next previous first and last. So this will compare the data with next first and last. So this is we are applying a primary calculation and then we are applying a secondary calculation. So first primary calculation, what does it do is it will do a running total basically. And the second one is comparing the value with the previous month and it is giving the difference. So that is about secondary table calculation. So percent from calculation, we have seen percentage difference from calculation, calculating the difference with the previous value or the next value or the first and last. And yeah, so these are the list of differences that we can do. So one is we have this option by right clicking on the table calculation or by right clicking on the field that we pull into the workspace. So when we select previous, it calculates the difference between the current value and the previous value in the partition. And this is the default value which will be advisable by the Tableau. And next we'll calculate the difference between the current value and the next value. And first, it will always compare with the first value in the worksheet. So in Tableau, when we pull out these reports, so it basically, so there will be a first and there will be a last value. And also we have this option called previous and last value. And now let's discuss about table down and table across. Yeah. So we have this option of doing average and median. And now let's discuss about how we can do this average in Tableau. So let me just show how average can be calculated. So it will just do a sum of all the values and divided by the number of items in the document. And so this is normal average that Tableau also does. So let's pull out this report category and pull out the sales. And I'll just make a duplicate of this one and I'll keep this one. Okay, and I'll just make this as an average. Yeah. So basically what is it doing is, so let me just show you the data. So these are the number of records for only furniture. So there are 2,121 records for furniture, and we have 742,000 sales. So 742,000 divided by 2,121 gives you the 350 average. So for each and every record, so in an average, they have spent $350 of sales. And in the same way, we also have a median calculation. So let me just show you how median is calculated. So let's say we have a data like some value. We have some values like this. See, these are dimensional values, and I have values something like this. Okay, so how median is calculated is, so if we have this values 2, 4, 5, 6, 8, so it will be arranged in ascending or descending order. Ascending or descending order. And so if the number of items are odd numbers, let's say we have 5 items here. So the number of items are odd, then the middle number is your median value. Median is 5. And let's say if your items are, the count of your items is even, then yeah. So even then we need to arrange it in ascending or descending order. And in the middle, we need to fetch these two values, 5 and 6. So we need to sum up these two, 5 plus 6 divided by 2, which is 5.5. So this is your median. So there are two cases. One is odd and even. So if the number of items are in odd, then we will pick the middle value. If the number of items is even, then we will pick the middle two values and do an average. Now let's talk about how to calculate the rank in Tableau. So let's take sales as an example. And now let's take any subcategory. I'm just taking subcategory. I'll just sort it. I'll just make it as a table. So this is a cross table. And I'll make sales one more copy. Yeah, I have a copy here. Okay, so this is normal sales without doing any table calculations and all. And now I will apply table calculations on the sales copy. So I'll go to quick table calculation and click on rank. Okay. So what is it doing is whichever has the highest value, it is assigning the first rank to that, and it goes on for all the values. So yeah, so this is how we can do the ranking. And there are multiple options. So I'll just show you how a ranking can happen. Okay. Let's say if we have, so these are the multiple options which are available: computation and modified computation, dense and limit. So I'll just show you. Computation. So sometimes in the data, we get values let's say we have 500 and the other one has 450, 450. So for the first person, we give first rank, and the second person and the third person have the same values. So in case if they have same values, Tableau will assign second rank for both of them. If we select the competition as the condition, it will just consider that value, and it will show for the third person. It will show you. Let's say we have a third person. Okay, we have a third person which is 670. Sorry, which is some 350. So instead of assigning third rank to that particular person, it will assign you fourth rank. So when we select this competition as a option, or let's say, and there is one more person, if you have 450 again, that means Tableau will assign again second rank for that, and for the fifth person it will assign fifth rank. So it will not assign that third, fourth rank to any other persons. That means it is assigning to this persons the same rank. Why? Because the value is same. And third, fourth rank, it will not assign to anybody if you select this competition option. And now let's talk about the other option, which is modified competition. So it's other way around. So modified competition. So let's take the same example. So, so in the same example, what happens is it will not assign the next value. It will just assign the fourth rank. Okay, it is like the continuation of this one. So here it is just after first rank, it is taking the second rank, and it is skipping the third and fourth. Why? Because there is no third and fourth here. Why? Because the same persons have the same rank, like third and fourth rank is assigned to the ADF and DKLA JF. So, but in case of modified competitions, it is other way around. So it is taken from the last rank, like fifth rank is assigned, and there is no fourth rank, so it will assign that fourth rank to these three persons. And now let's talk about dense. So I'll take the same example of data. Dense. Here it will not skip any ranks. If the value is same, it will assign same rank, and now it will not skip third or fourth rank. It will just assign the next rank to the next person. And now let's talk about unique rank. Okay. So these are four options which are available, and we'll take the same example here. Same example, rank. Okay. In this case, it will assign for every individual, it will assign unique rank. Let's say according to the order of it is as order of the data that is coming into the database, or the order which you are assigning to the worksheet, it will specify the rank to that particular person. It will assign 2, 3, 4, 5. So there will be unique rank for every individual person. So that is about rank. So let me just type it over here. So in this case, let's say we have different values for different categories, subcategories. So there is no value where you see it is not same across. So in that case, what happens is there is no way you can see this articulation. So that is why I have given you an example over here. So if you have the similar data for two individuals or three individuals, so then only we will make use of these four options. So mostly we use this one. Why? Because we assign same rank to the person, and if the values are same, we'll assign same rank, and to the next person there will be a continuation of the rank. So mostly we use dense rank, and for rest of the cases, depending on the requirements, we might use computation or modified computation or unique. So yeah, now let's go back to the PPT. Okay, so this is the rank type usage. So we have four options, which we have seen already. And yeah, and we have an option to restart, restarting every option. So every time we can restart from month and year. And if you are putting 2-3 dimensions in the worksheet, we can restart at any point of dimension. So now let's see how we can restart the table calculations. So let's put sales copy and order date. And let's make this as month and year. And let's put yeah. So we can see sales and sales copy at the same time. And we also need to put year of order date. Yeah. And now let's say if I'm doing a running total. So running total, what happens is it will do till all the years, which will give you total sum at the end. But I don't want to do for all the years. I want to do only till every year. Like 2017, I want to see 2017 total at the 2017 end, and same goes for all the years. Instead of seeing all the total sum, I want to see year by year. So I'll just click on this and click on edit table calculation and click on specific dimension. Okay. So here we have an option to restart every year of order date. So we can see the change. So let's say we have December 2017, and again it is starting with January 2018. So it is still continuing here. So we have not made that change right now. So 484,247 is getting added to the January 2018. So when I make this restart every year option, so what happens is it will restart every year. Okay, so it ends at December 2017, and again it restarts at January 2018. So it restarts in the sense it will start from the starting. So you will have January 2018 value as is, and as it is a running total, it keeps on adding the values till the year ends. So this way it happens for all the years. And now let's see the data. I'll just put this year and I'll put water data. And sales amount. Just make this as discrete. And make this as month. let's go back to the PPT. Let's put sales overview and sales copy. We will make this as table. So here we can see data one by one, and let's put this year order date on the top. Okay, yeah. So here we have sales data, and here also we have sales copy, which is same as sales. And now let's put month as well. Yeah. So we have monthly data and quarterly information by year as well. So now let's see. So there are multiple options where we can do table across and table down. So let me create a running total now. Okay. So basically this is our normal sales and this is the table calculation that we applied on the sales. So now it is doing the computation based on the table across. So what does table across means? So it will do operation across. So vertically it will do the, horizontally it will do the operation and it will stop over there. And again it restarts in the second row and it will do the horizontal operation. When I say horizontal operation, so we are, in table calculation we are doing running total. So it will add this 2. So it will add this 2 and it will give the value for this next value. So it will not consider month or year or any particular dimension. It will just go on and add the next value. So what is it doing? It will just add the next value. So 2017 January value is added to 2018 January, and all these 3 values gets added to the 2019 January. So this is operates horizontally. And now let's see how the computation happens when you click on table down. So in the name only it is mentioned that the operation will happen in the towards the down. So it will add January 2017 value to the February 2017. So 14 to 37 plus 4520, which is your 18757. So same goes for all the till the bottom it happens. So the sum will happen till the bottom. 484247. So same goes for all the months and years. So that is about table down and table across. So table across operation will happen towards horizontal and table down operation will happen towards the down. And now let's do the computation table across then down. So it will go horizontally and then it will come down. And again it will go horizontally and then goes down. So it will add till 14 to 37 plus 18174 plus 18542 plus 43971. Then again it goes back to February 2017 and it will add on like this. Like this. So that is about across then down and down then across. So it is other way around. You will go keeps on adding till down and again it goes to up and again it goes down. So it's a chain process. So till the end you will have the total sum. And we have pane across. And in our previous session we have discussed So this is called as entire table, and all these small blocks called as pane. And each and every value will be a cell. So this is a cell, and this entire thing is called as pane. So this is one pane, and this is one pane. So all these are panes. So in total, we have 8 panes in this particular table. So and this entire thing is called a table. And if you see these computations, so we have done table across and down. So we are doing for the entire table. So now we are going to do only for pane. So pane level. So we are doing pane across. So pane across doesn't matter. Why? Because even for table and even for pane, it doesn't matter. Why? Because it is just doing horizontal. For pane down, it matters. Why? Because here it ends. Again, it starts in the next pane. But in case of pane across, there is no end for that initial pane. But or if you are going down, you have a end point in between. So that's why it ends here and it starts again. So it happens 4 times as we have 4 quarters. And pane across and down. So here we can see, so it will go towards horizontal direction and again it will come down and again it will go to horizontally and again it will come down and it ends at the pane down. I mean, as this pane ends here, it will stop adding till here and again it starts in the next pane. So this is the operation that happens for pane across then down and pane down then across. Yeah. So this way it calculates till down and then across. So it will go down and again goes to the upwards and it will add the sum up. And the computation using cell. So if you do the cell computation, you will get the same values. That means you are comparing every time with that particular cell. So there is nothing you are adding or nothing you are deleting. So there is no change in the value. So it will be able to see the actual value as it is. And compute using order date. So if you are computing based on order date, so it will do based on order date. Let's say, so when you put the date in the table, or if you are taking a date into consideration, so Tableau will automatically arrange it in an hierarchical order. So January 2017. After that, February 2017 will come. There will be an order justification for Tableau. So that's the reason Tableau will automatically add based on the order which is there. So it keeps on adding. So January 2017 value will be added to February 2017. So it keeps on adding till the month, till all the years. So at the end you will have the total value. So this is how table calculations are calculated. So this is the procedure for all the table calculations and the list of table calculation. So here are the Tableau data sources that are available. Let's click on those data sources. If we drag it down, we can see the saved data sources of Tableau. So let's log into the database. It's taking some time. Yeah, so now we can see this particular data. So let's put customer name over here. Let's write replace function. I'll consider customer name. I want to replace, let's say, AN with let's say EN. So wherever there is AN, I want it to be replaced with, let's say, let's change this N also, EH. Say apply and put this replace over here. So wherever there is AN, that will be automatically replaced with EH. So this, and let's go to here and let's select string. And yesterday we stopped discussing about this regular expression. So let's see how this regular expression works. So let's create a new calculation. We don't use that regular expression much, but let me explain you how it works. So regular expression. So what it does is, so it will look for certain pattern. So let's say here is a pattern. So ABC123 or something like if you see email IDs, we will get some email IDs like @Gmail or @Yahoo.com or some organization.com. So you will get there is a pattern for any particular data that you have. If you see our bank transactions, you will see certain pattern for that particular bank transaction. So in such cases, what we do is we mention that pattern over here. So if you see in this particular ABC123, the pattern is, so it is taking A to Z. So here they might enter some A to Z letters. So we need to specify A to Z. And there is a space in between. And we need to mention that space as well. So to mention that space, we need to use this backslash and yeah. And we need to tell that we are using some numbers. So to say that are numbers, so we need to mention like this. So this is a pattern. So we need to mention this in quotes. Okay, so this is the pattern that we have. So whenever you have, let's say ABC123, so you will be able to see, let's say you want to separate 1 to 3 from that. So let's go to a new sheet. We put this regular expression. Yeah. So if you have data like this, so you will be able to connect to this particular information and get the data in such a way. So let's say you might have some D over here. Still you will be able to get the pattern. So let's create some sample data for that. So in Excel, I'm creating one sample data. Okay, let me take pattern. And there is also, let's say, sales or let's say amount. Okay, so let's say I will enter ABC123 and ABT123 and 123 or 325 something like this. So this is my data. 450, 550. It's like, let's say you have a bank transaction. This is, let's say this is a bill number and this is some ABC organization or ABC hotel or something like that. So if you have this type of data, and let's say I'm saving this particular data, and we'll save this as pattern, and save. So if I'm taking this particular data to the Tableau, okay, and I'll come to that particular Excel file. Pattern. So Tableau will automatically pick this sheet one. Then let me go to sheet 3. So if I put pattern 3 here and the amount, so I could see this amount. But what if I want to separate these two? So if there is a pattern, if you want to separate that particular thing, there is a way where we can do that. So if we can use regular expression where we select pattern and mention the pattern as, so what is there in the starting, A to Z, A to Z, comma, there is a space, space plus we want to write the numbers. To get the numbers, we need to do this. Okay. So this is what our regular expression. So let's put that. So in that way, what it does is you are getting this particular values. So separated. So this is how we can create a regular expression calculation. So this we don't use it much. So why we don't use it much? Let's say you have this pattern and you want to separate this. So there is a direct option which is available, which is a split. So you can do a split over here. You can do a custom split or you can do a normal split. So what it does is it automatically splits to two different things. Let's say it is separated with a space, right? So now it is, let's say you put this split one. So which you will get the starting letters and pattern split 2, so which you will get the next set of reports. So this is how you can directly transform the data by just going into transform and do a split. So if you go to custom split, so instead of separating it with a space, you can put some full stop or you can put any slash symbols or anything. If you have any full stops or anything in the data, so you can separate it with that particular data. So this is how we can make use of this regular expression, but we don't use it much because apart from using the regular expression, there are other calculations where we can use the split function. So split function is also one of the string function. So which automatically writes this particular calculation. So let me write it and show you the split function. Okay, so let me take this pattern or let's go to our superstore data. Okay, and let's take customer name. Okay, and I'll write split. So I want to split first name and last name. So here we have a first name and last name. So I'll write split. So I'll write split and customer name. And so the separation is space on space. I'll give space. And then I want the second name first. Okay, so I'll write this as split last name. So I will say apply. So split last name. So here you will get Bergman.
After the customer name, you give me the single quotes, right? It's gonna separate the values.
Yeah, so I'm just telling the Tableau that here is a separation based on space.
Okay. And you gonna give the space here?
Yes.
Okay.
Let's say
And why you
if I put dash, so there is no dash here, right? It is not separated with dash, so you won't get any. You'll get null. It is separated with space only. So I'm telling Tableau that I have a data which has a space in between. I want to split it based on the space.
Okay.
So if I don't put space also, it will not take. See, I'm getting error.
No.
So we need to mention what it is separated with.
Okay. Yeah.
I'll tell you one example for dash.
And also, why do you put the 2?
Yeah, this is the second position. You want the first split or you want the second split? See, we have 2 splits, right? If you split this thing, you will get error and bugman. You want the error or you want bugman? That information you need to. Let's say if you put one.
Okay.
Yeah. Like this.
Yeah.
So that is what, let's say, yeah, so this is one thing. I will show you one example for dash as well. So customer name, I'll create a calculator for that. I'll write replace first of all. So if in the data, if you have dash, so I'm first I'll replace that space with dash.
Okay, then it will show the 8.
And then it will be separated with dash. See, instead of space, I'm putting.
Okay. Yeah.
Now I will write split function for this separated with dash. Split for dash. So now I have to write split separated with the dash, where it is separated with dash only. So I need to mention that dash. Then I want the first one. Okay. I put this, so I'll get the first name from here. So in case of this particular column, if I put space,
okay, is
will I be
space? Oh no,
I don't get anything.
Yeah. Okay. Yeah. Now it.
We need to mention that this is separated with the dash, so that so Tableau should understand. You are trying to split it, but what are you trying to split on basis of what? So that we need to mention.
Oh, okay. Yeah. If you split again, you need to put another query, right?
Yeah, correct. And okay, so that is about display. And there is one more thing that we can do. Let's say we have different names together. Let's say in case of now, let's say this, but you have these 2 columns, right? Split last name and split for dash. So these two are two different names. You want to combine two.
Yeah. First name and last name. Yeah.
Let's say from data itself you are getting differently, so you can combine that also. I'll show you how to combine that.
Okay.
So split with, okay. Just select those 2, control select those 2, and go to create, and you can create a combined field.
Combined field. Okay. Yeah.
Yeah. So now you will get a combined field. Combined field based on comma, or you can edit that, I think. Edit combined field. Yeah, instead of comma, if you want to put space, you can put like this. So it is changed. So this is how there are some transformations which we can do by just doing right click and we can do the transformations.
Okay. Yeah.
Let's go to stream. And okay, so we haven't discussed about atom. Let's discuss about atom. So if you have any spaces after the letters, then you can remove those spaces by writing the atom function.
What is RTRIM?
So yesterday we have discussed about LTRIM, so which removes left side spaces.
Oh.
So let's. So RTRIM is the function where we can remove the right side spaces. So I'll create some data. I'll just create if customer name is equals to Aaron Bergman. So let's take this simple one. Control C. Pick last name.
Yeah, and one more thing. Actually, no. Why we are putting like open braces and small braces? Oh yeah, is braces for the every time we write the function, right? Calculations or anything. Is it mandatory to write?
See this thing. Let's say this is the field which is there already, or which is coming from the database, or it might be a calculation.
Yes. Yeah. Then we should. So yeah. If anything comes from the database, we need to put the bracket, right? Then.
We need to put the
For
bracket.
example, if you take the for example, if you take the customer name, right, you need to put that one in the bracket.
Yes, you don't need to do that. It will already. You can see that name, right? When you are typing customer name, so in the drop-down, it automatically comes. You can just click on enter.
Yeah.
So it automatically keeps in the.
Yeah. For the split
brackets.
function, yeah, I know you are writing every time the brackets and that's why I'm curious how this one.
So split function, so this open and close brackets are that is mandatory.
Okay,
so
for the
if you
split
see,
function.
Not only split function, for every function, so there is
for
a pattern that if you see on the right side.
Yeah.
So this is how you need to write any function. So you will see how this function can be written. So split in the brackets, you need to mention the column name and what it is separated with.
Column name must be single quotes, or because before we didn't give the single quotes, right?
No, column name, it will show you. It has to be in the square brackets.
Square brackets, okay.
Yeah.
Yeah, that's what I'm asking.
Some example.
Yeah. Column name should be in the square brackets, okay.
Yes.
Okay, yeah.
And rest of the thing is similar to what Tableau is showing here. You have to put that in single quotes.
Okay.
And the number has to be number.
Okay. Yeah.
And this is a result that they are showing.
Yeah. Now I got little, yeah.
No. So I'm just creating a calculation field. If split last name is equals to around.
For this, you didn't put the open braces, right? Open brackets.
This is the calculation field. This column.
Oh, if it is already calculation field, we can't put the open braces then, right?
The open braces is only when you are using functions. So this is not a function. This is a column name.
Okay. Yeah. Okay.
So what I'm trying to do here is, So when this column is equals to Aaron, I want to put some spaces after that Aaron name to show that RTM functionality.
Okay.
So I'm just changing or manipulating this particular Aaron name.
Okay.
So whenever this becomes Aaron, then I want to write Aaron and some spaces. Okay. Else I want the same column itself, split last name. And okay, and I will use this calculation one. And I'll put this calculation one next to that name. So there are spaces after that name, but we are not able to see. Yeah, here you could see the spaces.
Okay. Yeah.
Okay, and now I will write ordering calculation on top of this calculation one. So ordering. So this ordering is a function. Now I will keep this.
Remove the right spaces. Yeah, it can remove the right spaces, right?
Yes.
Yeah.
So now I will take this calculation one.
Okay.
So calculation one is a column. So that is why it's coming in the square brackets.
Okay.
Okay. So and I'll click on apply. So I'll keep this R-trim next to the calculation.
You just put the R-trim and column. Okay.
Yeah, now I named this column as a R-trim.
Yeah.
Yeah. And so you understand the difference between a column and a function, right? So if it is a column,
columns. Yeah, I can tell that. Yeah, column will comes from the data and the function what we create in the calculation field.
Yes, correct. Now let's see whether the spaces are removed or not. So edit alias. Yeah, now the spaces are removed. So this is how we can identify or remove the spaces in the calculation. So I'll show you why
I use the I use the aliases in SQL. Give the space.
Yeah. You're asking a question?
No. I'm telling them.
Okay.
I'm using like 3-4 days.
Okay. And I'll show you. So in case of if you are observing, so we don't identify whether we have spaces or not. Let's see how we can check that. So split last name equal to calculation one. Okay. If these two are matching, we will get as true. If these two are not matching, then we get as a false. So let's see.
Okay.
Now let's put here.
Yeah.
See.
Yeah, false.
Adam is not matching. False. Adam is matching because we don't have spaces.
Yeah. Okay. Yeah. Now I understand. Just you want to give the equal to, then it gives the or false function, right?
Yes.
Just
correct.
Yeah.
Okay. Space. So we also have a function called space, and it is to insert space, or we can keep by using the space symbol as well. But here, if you want to mention like 10 spaces or 200 spaces, we can just mention the number, and you will get those number of spaces. So let's say if we take an example of Aaron Bergman itself, I'll use a replace function, which is customer name, and I will use So I'm applying this space calculation, and I'll put the next to the customer name. Just replace it with 10 spaces, but I will need to put space over here. So there is a space in between Aaron and Bergman. So that single space will now get replaced with 10 spaces. I'll say apply. Yeah. So now it is replaced with 10 spaces. In the same way, I can put, like, if I want to separate with 100 spaces, so it will get separated with 100 spaces. So this is how we can specify a number of spaces here. So with the normal, let's say we can manually also, we can put spaces here. Let's say you have kept 2 spaces, but we can't, let's say, automatically put 100 spaces, right? So instead of that, you can just mention, let's say, space of 10. So 10 spaces will be there like this. So this is how we can make use of space. That is one function, and let me create a new one. String, and yeah, split function. So split function we have discussed, and let's go to starts with. Yeah. So starts with is the function where we can assign, let's say, to identify whichever it starts with. Let's say starts with, if I'm taking current name, and let's say I want to identify the customers whose name starts with Aaron or whose name starts with Adam. So to identify that, let's say I'll put this. So if I'm using this, it will show me the customer, whoever starts with Adam, will be shown as true. Will be shown as true, and rest others will be shown as false. So there are only 3 names. It starts with Adam. So let's click on this and see what all names are there. So there are only 3 names. It starts with Adam. Yeah. And we can write multiple calculations like this. So if customer, if starts with Adam, then Adam, else customer name. So these are normal basic calculations that we can write. So which will replace the, so whenever there is a customer who starts with Adam, it will just show Adam, and for others it will show the complete customer name. Yeah. So this is how we can convert any particular string or any particular calculation by making use of starts with. So this is one thing, and create a calculator field, and let's see how starts with works. Okay, so we have seen example for R trim and L trim. So now let's discuss about trim. So L trim and R trim will remove the values of the spaces in the left side. R trim will remove the spaces in the right side. In case of trim, what it does is it will remove the left and right spaces. So whatever spaces are there in left or right, it will remove. So if you see the example here, so budget has some spaces in the left side and budget has some spaces in the right side. So in that case, what happens is it will remove those spaces and it will give you normal characters value. So now let's see. I think we have created a calculation one here, which has right spaces. And in the same calculation, I will put left spaces also. Calculation 1. I'll put some spaces in the left side. Okay, say apply. So you can see a change over here. So now we have spaces in the left side and we also have spaces in the right side. Say okay. Okay, so this is how we can see the spaces. And yeah, now let's write this calculation, which is a trim calculation. Trim of calculation 1. Yeah, this should be sufficient. Say okay. And click on trim calculation 1. Yeah. So now it has removed the spaces which are there in left side and right side. So let's see how it is removed. Edit alias. Yeah. So this is how we can remove the left and right spaces by using trim. So there is sometimes we get data like that where we get spaces in the data. So to remove those spaces or to adjust the data or to transform the data in a way where we can use it for our calculations. So let's say as we have done for matching. So when you want to compare one column with another column, so it is mandatory to remove the spaces or unnecessary spaces which are there in the data. And that's about trim. And we have a calculation which is upper calculation, or so which converts the characters into uppercase. And we have seen one more function which is lower, which converts characters into lowercase. So now let's see how to convert customer name. Apply, and let's use uppercase and put it over here. So it converts all the letters into uppercase. So there are some similarities for few of the functions. So yeah, so lower and upper. So if you see lower, it converts all the functions into lower, I mean all the letters into lowercase, and upper is a function where it will convert all the letters into uppercase. And in case of trim, we have left trim, we have right trim, which removes left and right spaces, and normal trim is it will remove both the right and left spaces. And this is for the position, to identify the position. Let's say from left side, first 10, if you want first 10 letters, so we use left function, and mid is a function where you can get the letters somewhere in between. Let's say from fourth position, you need all the letters. You can just mention mid of the column name, comma, fourth position. Or if you want from fourth position, you want only 2 or 3 letters, there also we can mention 4, comma 2. So then it will show us from fourth position, whatever are the 2 letters, it will show us. And right is a function where we can get last n letters. Let's say last 2 letters if you want, or last 3 letters if you want. We can mention that and then we can get that information. So these are the similar type of functions which has coincidence. So with that, we have completed these string functions and number functions. And yeah, so this is about all the string functions, and these are the number functions that are there. So with that, we have completed all the string and number functions. Let's see in the PPT. Okay, so we have covered replace, trim, space, and split functions, and how to create a string and all by using order IDs. These are some of the data flow that are there. And yeah, so this is some example for the Canada data, which is provided by the, let's say I'll show you one more data. let's go to create. Okay, so these are the sample data which are available, and let me open world indicators. Okay, so here we have some set of data which has some similar type of dimensions where we can create information. Okay, and there are some certain symbols where we see and identify which data type it is. So let's go to sample superstore. Okay, so if we click on this customer and we see this symbol ABC. So symbol ABC denotes that it has a string. Symbol ABC string function, string data type. And if we have equal to symbol before any field, that means it's a calculated field. It's a calculated field, meaning it is not coming from the notebook. It is not coming from the database. So if you see here, so customer name segment. So these all are coming from database. So this is the information which is already there in the database and separated with dash. This is the calculation that we have written. So let me click on this edit. Okay. So if you see here, this is a calculation field. And in case of segment, if you go and see, you click on describe. So we will get to know what is it. So it is a column which is a discrete dimension, and type it is a database column. So it is coming from the database, and what is the information that is there. So it has this consumer, corporate, home office. These are the members of that particular column, and from where it is coming from locally, United States. So all this information will be available for that particular column. But in case of the calculated field, if you see, here also we can go and see the describe. And we can see that information, and type it is showing as calculated field. So this is a calculated field, and this is not coming from the database. So whenever there is an equal to symbol for any particular string data type or date data type or any particular data type, so you will see this particular equal to symbol. So that means we can edit that calculation field or we can use it for any other calculations. So that is about ABC symbol. And we also have this T by F, which will be as you click on this. So you are getting some true or false. That means this is a Boolean function. So whenever it is denoted with a T by F symbol, T by F symbol, that means it's a Boolean function. So Boolean function in the sense it will compare two different things and it will show you whether it is true or false. So whenever it is it satisfies that condition, then it will show you if it is satisfying the condition. The condition will show as else false. Okay, so that is the main use of T by F. So if we go and open that particular calculation, so if you see there is an equal to symbol before that particular T by F, that means it's a calculated field. And let me click on this describe button. So here you can see type as calculated field, and you can see the values. It contains only true and false, and you can see the formula. So the formula says we are comparing two dimensions, whether they are equal or not. Yeah, so that is about T by F, and yeah, so the symbol which you see, these boxes identify hierarchy. So hierarchy in the sense, countries will have states, states will have cities, cities will have postal codes. So when I say hierarchy, so let me click on country. So under United States, we have different states, and in each and every state we will have different cities. In each and every cities will have different postal codes. So this is the hierarchy, and so Tableau will automatically identify this hierarchy, and it has kept created a folder for that. And whenever there is a hierarchy, that will be denoted with this particular symbol. So that is about hierarchy, and while using hierarchy, as we discussed in the previous session, so we can expand and collapse like this. So even user can access this particular hierarchy functionality. So if we want to expand this United States and want to see the data state-wise and the data by city-wise and by postal code-wise. So if I put sales over here, I can see data by postal code, but I want to see what is the overall value for by country. So this is my overall value, 2297201, which is my overall value. By state, if I want to see, this is my value, and I can sort it based on this. And I want to see by city, and now I want to see by. So this is how I can make use of hierarchy. So, and this symbol denotes hierarchy function. And okay, and we have a globe symbol. So globe symbol is nothing but that is a geolocation. Geolocation in the sense, if we have that particular symbol, so if we put here, and these two options will be enabled when you have a geolocation. So how we will get this geolocation? So whenever you give some state names or some country names or some city names, so you will get this automatically in Tableau itself. So if you are not writing the names properly, or if you are writing any spelling mistakes in some states, then it won't identify. If you are not writing for all the names, then it won't identify. But if the spelling and everything is correct, Tableau will automatically identify, and it will give you this globe symbol for that particular field. And now let's see whether these locations are identified or not. And let me click on that map. So it will identify those particular locations. So this is how we can, and as we discussed earlier, so longitude and latitude, these are some of the Tableau generated fields which will already be there. So based on those generated fields only, we can get this information. So that is about globe symbol. And we also have hash symbol. So that symbol which denotes a number data type, or float or anything, decimal, all the number related data types will be over here. Let's say float, decimal, number, whole number. So all related to numbers will be over here. So let's click on this and click on describe. So this is a database column, and so if you see in the details, you can see it's a double precision floating point number. So you will have decimals in that particular data type. So that information we can't see it as a notation, but if you go into describe and you will be able to see that information. And whenever you see this equal to symbol, that means it is a calculated field. So that is how we can create a profit ratio and all. So can you tell me what T by F stands for? What this symbol represents? That's fine. Okay, so T by F stands for it's a Boolean function where we can compare two different dimensions, and so that's about T by F and number. So this number includes all the uh, types of number data type. Let's say float and also decimal and also the whole number and everything. Everything almost covers in that as symbol. You could see double precision floating point number. And also, so here there is also an option where we can convert these particular data types. So if you see, these are the data types that are available and we can change those data types. So if you want to convert some number into decimal number into a number whole, so that we can do. And we can convert if you think that particular field belongs to date and time or date, then we can convert those columns into related data types. So that option is there. And in case of geographic role, also, we can change that rules from one to other. So by default, some of the options which Tableau will automatically identify, let's say in case of state, if you see, so state, it already selected the state or province. So for state, if it is selected some country or anything, you can directly go and select over there. But Tableau automatically identifies this thing. So we no need to do that. For city, it automatically selects city itself. And for postal code, it automatically selects zip code or postal code automatically. Let's say, I mean, in some cases, you might not be having the right names. Let's say for country, you might not be having the country as the field. Maybe sometimes it might not identify. So in such case, what you do, you go here and select country or region. So in that way, we can convert even the geolocation as well. So that's about today's session about the string functions and the number functions. And in tomorrow's session, we are going to discuss about the date functions, and I'll show you that functions that are going to discuss. Session we are going to discuss the rest of the functions which are available here. Okay, then we'll continue tomorrow. Okay, so in this session we are going to see how to connect to basic Excel and how to visualize the data, and what happens when we connect to data, and what are the by default things that Tableau does the data, like segregating the dimensions and measures, and identifying the data types of the fields that are there in the data. So, and what are auto-generated fields in Tableau. And today we are going to discuss about what is live and extract connection, and how to save the Tableau file as well. So now let's just create a table like this. So a table which has this information of region, and that region belongs to which country and all. So with this information, we are going to create one data. Now let's just take this data. So there are multiple ways you can keep the data to the Tableau. So I just copied that. So you can directly paste it in the Tableau itself. So I'll go to a new sheet. So we can directly paste it in the Tableau, or we can paste that in Excel file and we can connect that to the dashboard. So I'm just pasting it here. This is my data. Okay, this is taking some time. Yeah. So the thing is, we can copy the clipboard. So whenever you copy something from any PDF or from any of the Excel file, or if you are picking it from any PPT, so you can directly do a Control C, Control V, and it will be pasted as a clipboard. Tableau could not connect to the source. Okay, I will show you that in the next session. I think there is some issue while connecting clipboard. So now let's connect to Excel file for now. Okay, I'm just saving this file. Okay, so I'll save this file. Section 3. And I'll go here and select Microsoft Excel. And I'll select this session 3. So now I have, there are 2 sheets in the Excel file. So Tableau will not automatically pick the sheets. So we need to manually drag and drop the sheets into the data pane. Okay, so now we need to select so which one we want to show into the dashboard. So earlier we had so in yesterday's session we had only one sheet. So Tableau automatically took one sheet into the data pane here. So now we need to put this sheet too. Yeah. So this is how we can pull the data. Yeah. So by seeing this data, we can identify that this is an hierarchical data, let's say region, under that countries will be there. Like in APAC region, there are 3 countries, and in India region, there are 3 countries. So likewise for North America. Okay. So what happens when we connect this data to the Tableau? So Tableau automatically identifies country names. So whenever we give country names or districts or any city names, so Tableau automatically identifies that it has a country name or city name or the place. Tableau automatically identifies the location names. So what happens is it will give a globe symbol, so it geographical symbol, and we can create maps using this particular field, whichever is the country field or city field or district field or state field. So we can create maps by using this type of fields. And the ones which has globe symbol is useful to create map charts or symbol charts. And the Tableau also segregates dimensions and measures. So if you see here, so country and region are under the dimensions. And if you see the sales is a measure, which is a measurable, so that goes under measures. So now let's just see it in the live. So let's go to the dashboard. Okay. You see here, we have country region in one place. So these are dimensions and sales is a measure. So it got segregated and we have a geographical symbol here. So when I put this country over here, so I have this country names. So if I want to see geolocation of that particular country, so there is a map over here. If I click on that, it will show the locations. Let's say India. It will point to that particular location, and you can show. So what happens when we have a location, let's say if we have city names in the field, what happens when we connect to the Tableau, when we connect that field to the Tableau?
So if you have the fields and if we connect to the Tableau, it shows on here in the columns or rows, right?
No, that will become a geolocation like this. Let's say I have a field like city, so that becomes a column which has a geolocation. So when you put that field to the rows or columns, we can create a map chart like this.
Yes.
And you can show the sales or profit or anything on top of that particular location. So that user will automatically identify in which location it has the more number of sales or more number of profit. So that we can identify. Tableau will automatically generate few fields. So if you see in the data, we have only country, region, and sales. So if you see, I have pulled only these three columns. But apart from these three columns, I also have extra columns, which is measure names, latitude, longitude, and number of records, measure values. So these are the by default Tableau generated fields where we can use it for our calculations. So latitude and longitude is something which comes only when you have some geolocation, like country, city, state. Whenever you have this type of field, then only you will get these two, latitude and longitude. So this map is getting generated only because of these two fields, latitude and longitude. So whenever we are keeping this country and selecting map, so latitude and longitude will be automatically kept in these columns and rows. And based on that only we are able to see we are able to point that particular location.
Okay.
And number of records, to see how many number of records that are there for the entire data or for each and every field we can see that. So let's just it is named as sheet to count over here. So let's just see. So there are 9 records. So let's go to the data. And if you see, we have 9 records. So see the number of records. And if you want to see how many records that are there for each and every region. For each region, we have 3 records.
Yeah.
So, yeah.
Sales.
If we go to data, so if you see for APAC, we have 3, for EMEA 3, North America 3. Okay, so now let's talk about the auto-generated fields in Tableau. So measure names and measure values. So these two are very important while creating multi type of charts. Let's say you are creating dual axis charts or any type of dual charts. We can use these particular measure names or measure values. So now let's see what does this measure names and measure values contains. So measure names, in the name, in the title itself, which is there that it contains the names. So it contains the header names of all the fields in measure. So let's say you have sales, you have profit, you have discount. So you will have a lot of measures in your data. So in that data, so you will be able to have all the names of these particular measures in one particular place. So that is what is measure names. So in case of our data, so let's see. So in case of our data, we have only one sales, one measure, which is sales. So if we go here and put measure names, measure names. So we can see sales and count of sheet 2 is also a measure. So this is a by default one, which Tableau will automatically create. So we need to use this combination, measure names and measure values. It's a combination. You can't use one at a time. So let's say if I am using only measure names, so I don't see anything. It won't show anything. So otherwise, if you are using measure values, it will show the combination of these two measures. So that, but there is no way you can sum up these two. Let's say sales is some different measure and the count of records. So let's go here. Okay, 3,400. So it is showing both of them in one place. But the thing is, we need to show both of them differently. So what we need to do, we need to keep measure names. So measure names, if I keep it, sales we have 3,400 and the number of records are 9. So to segregate that particular thing, we need to have measure names and measure values. Now let's see. So this particular field, measure names, is used to create advanced level of charts in Tableau. And measure names can be filtered or to restrict the number of measures or KPIs to be shown in the chart. So
can you tell me about this KPI, key performance indicator? What is that?
Yeah. KPI, key performance indicator. So key performance is indicator is nothing but which defines the performance of your organization, or based on this particular KPI only, we will get to know how the business is performing. So whether if there are higher the better KPIs and lower the better KPIs. So when I say higher the better KPIs, let's say sales.
Oh,
Profit.
what is that? Higher, better KPIs, right? You're talking about higher, better KPIs and lower, better KPIs.
Yeah. So let's say you want your sales to increase and you want more profits. Let's say if you are selling something, you expect that to get more profit. Let's say you buy some, sorry, you're selling some iPhone, let's say for 1 lakh, and you are getting 20K profit. Or if you want more profit, like 25K, 30K. So these are higher the better KPIs. Like profit is a, you want more profit, right? So in such cases, so profit is called as a higher the better KPI. So if you are getting high profits, that means it's good.
Okay.
And there are some lower the better KPIs. Let's say cost. So when I say cost, let's say we have a product and we sold that product to the customer. So for some 1 lakh, okay, and we got a profit of 20K, and cost for that product. What I mean by cost is, let's say after selling the product, we will give warranty to that product, right? And while manufacturing some products, we throw some of the scrap. Let's say if you are manufacturing some any, let's say iPhone only, so you will have some scrap for that particular material. Like, yeah, you are using some material to create that iPhone, and there will be some scrap which you will throw out. So those are the things which are going to be your cost. So that will become, so you want your cost to be less. So let's say if a user comes to you and complains about your iPhone, and you want to give, let's say you have to replace some part of that particular iPhone. So you will be putting some cost on that. Like out of your profit, you might put some 5K or 10K. Okay, if you are putting more cost on the product, that means it's a loss for you. So that will become your lower the better KPI. So this has to be low. Like you should not put any more cost on that product. So you are getting 20K and you can't put more than 20K like that. Is it clear? No?
Yeah, continue.
Okay, so this in any organization this will be there, like higher the better KPI and lower the better KPI. So and while creating the charts, what we do is, let's say if a sales crosses 500K, so we show that in a green color. So it's a higher the better KPI. Let's say greater than 500K. For higher the better KPIs, we show it like that. And less than 500K, we show it in a red color. Like we should get sales of 500K, more than 500K. These are like targets. In case of lower the better KPIs, what we do, it will be the opposite. The target should be, let's say if you are taking a cost as an example, greater than 10K, which should be in red color. Why? Because this KPI should be lesser the better or lower the better. In green color. Okay. So this is the kind of representation that we do in Tableau. And not only in Tableau, in reporting standards, what we do is there are 3 colors. Let's say red, green, and orange. These are the 3 colors we should not use without necessary usage. Let's say in case of this particular condition, So I'm saying if it is more than 500K, that should be in green color, and if it is less than 500K, it should be in red color. But you can't use it for normal simple reasons. Let's say I have created a bubble chart here. Bubble chart. Okay. So I have this particular chart. Here I am using some colors which represents segment, consumer, corporate, home office. Here the home office is in red color. So I should not use red color for home office. Why? Because I'm not representing that home office is bad in something. So I'm just representing some color for each and every segment. I'm not saying home office is bad. Okay, so if you are saying something, let's say if you want to show something or highlight something as performing bad or performing good, then only we use these three colors. Orange is for moderate. Okay, is your question clear or any doubts?
Yeah, no.
And we use measure names for multiple to create multiple line chart or combination chart. And measure values contain all the measures, and this can only be used with a combination of measure names and measure values. Now I will show you how to create multiple line or combinational chart by using these two things. So let's go. Yeah, so I will take sample superstore data. Okay, and I will show you measure names. Okay, so these many measures are there in this data. These many measures are there. So I just want to see few measures. So if I put measure names, so in the filter and select this, see, these are all measures: profit ratio, sales forecast, days to ship actual. All these are measures. So you can just directly select whichever measure you want to show, like sales, profit, and then select OK. So you will be able to see only those two. And now I will show you the combinational charts. So I'll just date, okay, and month, and I'll select a line chart. Okay, like this. So the black one is sales and the pink one is profit. So likewise, I can show both the measures at a time, or any of the one I can make it as a bar. Yeah. So one of them I can make it as a bar, and the other one I can make it as a line chart. So this is the advantage of measure names and measure values. So see, I had Tableau automatically kept that measure names in the color. So each and every measure represents in a different color. Profit is in this color and sales is in that color.
Yeah.
And there are other fields as well: longitude and latitude, and the number of records. So this is also an auto-generated field in Tableau, which will get generated if we have any geographical information in the data. Let's say country, state, city, district, or pin codes. So all these things will come under geographical information. And for every geographical information, Tableau will automatically generate longitude and latitude for that. So these fields will help locate the state, country, city, postal code in the maps. So these are automatically generated, and if needed, depending on the requirement, we might need to. So manually, sometimes we create a longitude and latitude fields to create some flow map charts. Like if you want to connect some state to other state, let's say you want to connect Delhi to Mumbai, Mumbai to Karnataka, like that. So we might need to create a few longitude and latitude in the data level, and then we can connect those points. And number of records, it will give us the information about the total number of records in the table. Sometimes this field can also be used in the calculation. So now let's see about this longitude and latitude. Let's go to our data. Latitude and longitude. So it is not showing anything, but we need to keep the country in the detail. Yeah, it is showing normal geolocation. So now let's select map. So select this map. Okay. Or you can directly put automatically. Okay. So with this longitude and latitude, we can see the exact location of the countries. Okay. So live connection and extract connection. So now let's talk about live connection. So live connection is represented by a single cylinder. So by default, whenever you connect to any database, so it will be in live connection. So now let's see. So now I have connected to this Excel file. So by default, it is in live connection, live mode. And you can see that information here as well. So connection is live. And here also you can click on extract. So while going into the sheet, it will extract the data and it will show you. Okay. So live connection is like connecting to the data source directly. So whenever some change happens in the backend, so it will automatically reflect in the Tableau. So it is better to keep dashboards in live connection in case you have data which is updating very frequently. So in case of data, let's say stocks, so you want that data to be updated very frequently. In seconds, it has to be updated. So in such cases, we go for a live connection. So by default, whenever we connect to any data source, it will be in live connection, and it is denoted by single cylinder as shown in the title. And yeah, so that is about live connection.
Yeah.
Extract connection is like connecting to the snapshot of the data. So at that point of time, whatever is the number of records which are available. So let's say you have 100 records in the data. So it will take those 100 records into consideration, and it will save it in the dashboard level. And later, in later point of time, the data is getting updated with 120 or 150 records. Tableau will not take those records until unless we do a manual refresh or a scheduled refresh. And extract has to be done manually, or scheduling can also be done. So now let's see how to extract the data. So now I have this live connection. So now I'll right click on that particular data source and click on extract data. So we will have lot many options. So while extracting the data, also we can put some filters. So we can select the country if you want to pull out only one particular country or one particular region or anything. So we can apply those filters here. That's a region also. So I just want only a packed region while extracting the data. Instead of getting all the three regions, I can filter it out here itself. That is one option. I need all the regions. Yeah. And aggregate the data to visible dimensions. So let's say you have country region. So these are the two dimensions. So it will aggregate by default, it will aggregate to the country and region level. So whenever you refresh, it will refresh. Let's say you have 100 records, it will refresh all the 100 records. And next time when you have 110 records, next time when you do a extract refresh, if you have 110 records, it will upload all the 110 records again, like from starting to, it will remove the existing records and it will extract the 110 records. But when you do an incremental refresh, we can apply to identify new rows. Let's say you have 100 records in the database. If you are pulling out 100 records, and the next time when you are pulling out extra 10 records, so it will not delete the existing records, but it will find out whatever are the new extra 10 records, and then only it will fetch the data. Okay, we can specify that particular logic as well. Tab table to refresh sheet 2. So based on the, we should give some column name which identifies the new rows, and then it will take the data. So now let's just put all rows. Why? Because we are pulling it for the first time, we need to pull it all the rows. But when while refreshing for the next time, you need to click on the incremental refresh, and mostly in the data you should have date field. Based on the date field, or you should have some IDs. So based on the IDs or the name, date field, you can do an incremental refresh. So now I'm doing extract. So it got extracted. So that extraction will be shown in a double cylinder. And that now the data is attached to this Tableau file. And also, so it will not take any updates from the file from now on, until unless you refresh or until unless you refresh or do the schedule refresh, it will not update the data. So it is generated with a double cylinder like this. So extract can be done by right clicking on the data source. A new window gets open to apply the incremental load or top rows load. So that is the process to extract the data. And once the extract is done, but you want to go back and keep the data source in a live connection. So we need to uncheck this use extract. So now, then it will become live again. So you can do extract like this. And when you want to go back to live connection again, you need to hit this one. So this is the procedure to create a live connection or an extract connection. And as we discussed in our previous session, so depending on the requirement, we keep the data and extract our live connection. Let's say in the case of data, if you are getting by monthly or weekly, so in that case, then there is no point of keeping the dashboard in a live connection. Instead, we can keep the dashboard in extract mode and put the schedule refreshes for weekly or monthly. Okay. Now let's talk about the extensions and how to save the workbook. So let's see, and I think yesterday we discussed about this particular topic.
Yeah, yesterday we discussed about TWX and TBX. Yeah.
Yeah, we discussed this. So these are the two options which are available, TWB and TWBX. Okay. So TWBX stands for Tableau Workbook Extract, which is a packaged workbook. So Tableau Workbook Extract contains all this. It contains data, images, custom color palettes, and also visualization. Okay, so
Basically, it contains everything what we did, right? Data, visualization, and everything. TWBX. Whereas the
Yes.
TWB doesn't have the data.
Yeah. Yeah. So TWB won't have this data, images, custom color palettes. It will only have this visualization.
Okay.
So when you connect to the data, it will have some images and custom color palette. Let's say when I say custom color palette, see, I have this color for profit and sales, right? So when I save this as a TWBX and I send this to you, and you will see these two colors, same colors. But if I'm saving this as TWB and in your PC you are connecting to the data, you might not be able to see the same colors. Why? Because these are the custom colors which I have selected. In your PC, you will be having this custom colors according to your PC.
Okay.
Okay, so with that, we completed this session 3. So do you have any questions in session 3 before we go into session 4?
No, so far good. Yeah. Let's continue with session 4.
Uh, so in this session, so this is about organizing the data pane, and there are some default settings. So yesterday I just showed you how to put the default settings for aggregation. So today we are going to see more options. Not only aggregation, we can put some default setting for shapes, for colors and everything. And about combined fields also we are going to see. These are the topics that we are going to cover. So we can create hierarchies and basic usage of calculation fields. So most of the time in Tableau, we just use the tool. Let's say it's a drag and drop tool. So we just create charts by dragging and dropping the fields into the workspace. But there are some calculation fields that we write, like there are some calculations by using if else statements and by using case statements, we write some calculation fields. So today we are going to discuss about few of the calculation fields which are basic.
Okay, yeah.
How to edit a calculation field and all, and about dimension and measure. And there are some blue fields and green fields in Tableau. And what are those green fields and blue fields in Tableau? And we have some 40 to 50 functions in Tableau. So if we learn about those 40 to 50 functions, then it's easy to write the calculations and everything. So with that, all the functions, we will be able to create or visualize anything in Tableau. So when we connect to data source, Tableau automatically separates date fields into hierarchies. So you can easily break down the visualization. You can also create your own custom hierarchies. Okay. So Tableau automatically, a few of the things Tableau will automatically understand and it will create the hierarchies. So in case of date, so date you won't have any, let's say how we are entering the date. Okay, so we are entering the date like this.
Okay.
And I'll just show you some data. Okay, so we have the date like this. Okay, and Tableau, what it does is it automatically creates one kind of hierarchy. Let's say 2018, there are 3 records here, and there is one more 2018 here. Likewise, in the entire data, like if you want to see the 2018 data, and in 2018 you want to see January data. So if you want to do that, you need to have some kind of hierarchy. So Tableau will automatically do that hierarchy for us. So when we have date in the date format, Tableau automatically does it for us.
Okay.
Let's say order date. So yeah, if you see, if we have 2016, 2017, 2018, it automatically segregated. So if you are seeing sales for this particular years, so it automatically segregated. So what it does is that's the order date. So what is it doing? Years, let's say 2018. If you want to calculate the 2018 sales, what is it doing? It will select those sales data for 2018. It will select that 2018 data and it is giving us the sum of sales. So likewise, we also have so many options. Okay. So if you see, we have year over year and year also year. So I will tell you what is the difference between this quarter and this quarter and this month and this month. So basically this year and this year is both are same, but this is in continuous mode. So continuous mode, we can create charts, let's say line chart or something like this. But in discrete mode also we will have this chart. But you can see, but it is not in a discrete mode. So now let's talk about quarter. Okay. So basically we have 4 years of data. If you're seeing order date, okay, we have 4 years of data. But when I make this as a quarter, it is showing you quarter Q1. So what is it doing is, it is having 2016, 2017, 2018, 2019, all these 4 Q1 sum of sales is in this particular field. Likewise for all the Q2, Q3, Q4. Okay, so this is what is this quarter. But when you go for this quarter, here you see quarter and year. In this case, you have only quarter. So here you will have quarter and year. So each and every quarter you will be able to see the value. Let's make it discrete to see the correct values. Okay. So 2016 Q1, 2016 Q2, 2016 Q3. So earlier what happened when you select first quarter? So it is giving you Q1 value 2017, 2018 and 2019 Q1. All the sum 434067. So let's make this quarter 434067. So the usage of this, I mean the difference between this quarter and this quarter is, this is a combination of year and quarter, and this is only normal quarter. And now same goes for month as well. So this is only month and this is month and year. So let's click on January of all the 4 years, February of all the 4 years. And when you select month and year, it will show you all the months and years. Make it discrete to see the values. Yeah. It will show you all the month and year. Okay. So this is about, okay, let's see about day also. So day also 1, 2, 3, 4 till 31 you will have. So 1 of all the months, 1 of all the years will be there in this particular one. But in case each and every day, month and year, everything you will have in a separate thing. Let's make it discrete. Yeah. So month, day and year. So this is the advantage of date field. So when you have date field in a date format, then you can use this functionality. Let's say You can make year, month, date, weeks, everything you can segregate. But if you are not having date in a date format, then it's very difficult for you to segregate all the years in one place, all the months in one place. It's very difficult to maintain. So whenever you are trying to get the information, so everything has to be in a popular perfect format. So now we are talking about hierarchies. Now I'll just show you what is hierarchies. So you have this symbol which is expand. So when you click on this here, so from here you go to quarters, right? From quarters you go to months.
Month.
You go to
Days.
days. Yeah. Okay, this is the last hierarchical level or lower granularity where you can go. Okay, let's just swap. Yeah. And now you want to go back, or you can. Okay, so so this is at the developer level. So while publishing or while showcasing it to the user will not be able to see this row shelf or column shelf or this marks card, everything. He will be able to see only this particular space. So we can give this option to the user as well. So if he wants to expand or collapse, he can do it from here, like this. You don't want to show days. You don't want to show months. You don't want to show quarters, like this. Or you want to expand. Here also you can expand. So this is what is hierarchy. In the days, days together called as months, months together called as quarters, quarters together called as years.
Yeah.
This is the by default which comes from Tableau itself. Okay, and so when you have region, state, country like this, so Tableau automatically understands cities together called as states, states together called as countries, countries together called as regions. So Tableau automatically understands that and it will create a hierarchy. So let's see.
What is cities called? You said country is called region, right? What is city called?
I don't mean that. Okay, so if you see countries together, I mean together in the sense, I mean APAC region has 3 countries.
Okay, yeah.
States, I mean
Asia Pacific, Africa, China.
in India we have different states. All the states together, let's say we have 29 states. All these 29 states together called as India. Like states together called as countries, countries together called as regions, likewise. So this is the hierarchy, right? Let's say insert state. State we have Karnataka, Telangana. Under India we will have all this, right? So this is a hierarchy. First India, then states. Then in the state, what are the cities? In the cities, what are the pin codes? This is the hierarchy. So what I'm saying is, so Tableau will automatically identify countries. Under the countries, we will have states. Under the states, we will have cities. So this regions and locations, Tableau will automatically identify. So that's how it creates. See, you see the location. So this is in a hierarchical order. So let's say if I put this region and if I expand, Under central, okay. So there is only United States data in this superstore. So in United States, what are the states? So these many states are there. And in each and every state, what are the cities? And in each and every city, what are the pin codes? Like this. So this is the hierarchy which Tableau will automatically create. I'll tell you one more. Let's say in any organization, we will have manager. Under manager, we will have 10 employees. Okay. Let's say 10 tech leads, if you say tech leads. And under each and every tech lead, we will have 2 employees. So that is the manual hierarchy, and Tableau won't understand that. For that reason, what we do, we create that. Let's say okay, so let's say here we see country and region, right?
Yeah.
Okay. So Tableau mostly identifies only the country names. So APAC, EMEA, these are the normal abbreviations that we keep. So Tableau doesn't understand this particular abbreviations. So that is the reason we don't create any hierarchy for that. So now what I will do is I'll just select region and I'll go to hierarchy. So let's create a hierarchy. I'll drag this country and put underneath the region. So now you see this expansion. So now if we expand this, we will get countries under the region, and you can collapse like this. So earlier you didn't have this option. So I'm just doing Control Z. So before doing hierarchy, when I have this region, see, you don't have that expand collapse symbol. So you can't expand. You need to manually keep this country over here. And you don't get this option here. So it is to give user option to select the hierarchy. So you create hierarchy, like location hierarchy, and put this country under the region. Okay, and put the region over here. And you can select the expansion or collapse. So under the region, you will have countries. Under the countries, you will have cities, or you will have states. Under the states, you will have cities. So this way, sometimes you need to create manual hierarchy. Is it clear? So when we connect to a new data source, Tableau assigns each field in the data source in the dimension area or in the measures area. So when we connect to any database or anything, the Tableau automatically segregates that dimension and measures. And so when you put any dimension in the field, so that becomes your dimension will be in blue color. So every time when you put any dimension, that will be in blue color, and we call this as a blue pill. We call that as a blue pill. So most of the dimensions will be in blue color, So with the color also we can identify it is a dimension. Most of the measures will be in green color. So this is not related to like user level. So user won't see this blue color or red color or anything. So it is just for our understanding, to understand what is dimension, to understand what is measure. So now let's see what happens when I put sales. So by default, when you put something uh, in the row shelf or column shelf, if it is a measure, so that will be in green color. And there are situations where dimensions can be in green color. Only in case of date dimension. Only in case of date dimension, we can keep that in a blue or green color. So now let's see what happens when we keep a date dimension. Okay, so now you see it is also a dimension. So whenever you put some dimension in row shelf or column shelf, it will be in blue color. But this dimension we can also make it as a green color. Why? Because there is two things called which is discrete and continuous. So continuous is something which shows like a flow. Let's click on this. Yeah. So now it is in green color. So to create, to make some charts or line charts or anything, so you use this continuous mode. So salary. Let's put the day over here. Okay. Okay. So with this, what happens is it will show like a flow. So that is the reason we make that as a continuous. So discrete, it will what it does is it will show discrete values. Like it will not show like a individual value. So discrete is something it will show only particular value by value. But continuous, it might miss some values in between. So let me just show you in another chart. Uh, let's say take sales and date or a date. So it is showing me this output where you can see all the years. Why? Because we have only 4 years there. And if I am converting this to a month, let's convert here. Okay. So this is now in continuous mode. But what I'm showing here, I'm showing month and year, but it is not showing me all the months, all the years over here. It is just showing me 2016 and 2017. But I can understand the flow of the line chart, whether it is trending up or trending down. But what if you want to see each and every value? So if you make it discrete, then you can see each and every month and year. But if you can't see the flow at a time, you are getting this scroll bar. But if you want to see only the flow, then you go for continuous mode. So with that, what you can see is you can see the flow, but not all the months and years. So that is the main use of continuous and discrete mode. So with continuous mode, we can convert a dimension from blue to green. So this is one thing, and measures can also be in blue color. In which case, Now let's see in what case the measure can be in blue color. So now let's put some region and some sales. Okay, so this is in continuous mode. In continuous mode, what happens is it will show some flow. So now it is showing axis. So with continuous mode, we will get axis, but it is hard to understand the data. For APAC, you have one bar. For EMEA, you have one bar. So instead of that, let's say in this case, I want to show a tabular chart. So in that case, what I will do, I will make it as a discrete. So I make this as a discrete, then I can see each and every value of that particular sales. Hello, Venkat. Is it clear or do you have any doubts?
No, sir. It's good.
Okay. It's other way around. When in case of measures with discrete mode, we can convert a measure into measure from green to blue. So this is technical information. This is not associated with a user. So it is just for our information, for knowledge purpose. So it just knows like what is this blue color and what is this green color. To understand about the difference of that, I'm telling you this information. Now let's see in the PPT. So dimension contains qualitative values. You can use dimensions to categorize, segment, and reveal the details in your data. And dimensions affect the level of details in the view. So whenever you keep any dimension in the workspace that I have shown, so it will impact the level of detail of the view. And measure contains numerical and quantitative values. So measures can be aggregated. So this is the definitions of dimensions and measures. Okay. So blue versus green fields. So most of the dimensions will be in blue color and most of the measures will be in green color. And there will be blue measures and there will be green dimensions. So that we have discussed. Okay. So these are the combination fields which are there in Tableau. Like this is the difference between continuous and discrete is. So continuous will show us the flow of the chart, and discrete it will show you the individual values, and it will also show the flow. But comparable to the continuous, it will the impact of the discrete is to show the individual values. Okay. Now let's start discussing about few of the functions in Tableau. So we have number functions and we have string functions. So these are the types of functions which are available.
Yeah, data types.
No, these are not related to database. These are Tableau functions.
Okay.
Okay. So these are the number functions. So these are the functions that we use while we write our calculations. String functions and all this.
Oh, okay. Okay.
Okay. So why we use number functions? So number functions allows us to perform computations on the data values in our fields. So today we will discuss more about this number functions also. And number function can only be used to convert the numerical values. So let's start this number functions. Okay. So we'll go one by one. So Let's go to Swamp Superstore data and let's put sales and I'll make it as table and I'll put some product of product. Let me just say something. Let's take segment. So segment wise, I'm showing this sales. Okay. And now I'm going to create sales. So there are many ways that we can create a character field. So you can click on this drop down and click on create character field, or you can go to analysis and there also you can see create character field option. And click on this number function. And the first function is ABS. ABS. For this, let's take profit as well. Okay. So in profit, we also have negative values also. These are the profits and these are the formatting is like this. Let's change this format. Okay. So you could see the negative values also. So what I'm trying to do with this profit is, I'll write an absolute. So absolute is a function which will not consider the negative sign or the positive sign. It will always show positive value. So absolute. I'm applying this. Absolute. I'll put it over here. Okay. So whenever we are writing some calculation, you need to put sum of profit. So sum is mandatory. Say apply and put this absolute over here. Okay. So now you see 49,993. So everything will be same. And in case of negative, what is happening is it is not showing you the negative sign. It is always showing you the positive sign. So these are some kind of requirements that you get. Let's say absolute and subcategory. Okay. And I'll write one calculation. First of profit less than 0. And then this is some simple calculation. I'm just writing down. Okay. So this is my color condition. What I'm doing is whenever my profit is less than 0, I'm just saying it is to the red. If I'm getting negative profit, that means I'm in loss. I'll put that color condition. See, like this. So what is happening? So I want to show my graph into the upwards only. Like I don't want to show in the negative side of it, but I want to show in the upward direction only. But I will show it in a different way. See, I'm in red color. Why is it in red color? Because I'm having negative profit. So instead of absolute value, what happens when you keep normal profit? So it will be in the opposite direction. Why? Because it is negative. But in some cases, user will ask for don't show it in the negative side, show it in the positive side only, but represent with a different color. So in such cases, we go for this absolute calculation. So that is one kind of requirement that users ask for. So that is about absolute. And okay, now let's create another calculation. And ACOS. So these are the some calculations or trigonometrical calculations. So if you want to use, we can, let's say, we can use this calculation, but these are not useful much because it will just show us the value of this 3.14. The cost of -1 is 3.14. What is it doing is it is summarizing the 3.14 value for all these accessories. So if you want to see that 3.14 value, you need to do an average. Format, make it custom. Yeah. So that is just trigonometrical calculation. Whenever you want to use that particular thing, then we go for this trigonometrics. The same goes for assign. So let's put assign, apply. So it shows us 1.57. Minus it is showing because I had kept minus over there. And same goes for A10. The description over here on how to write or how to use the functions. So we can they will provide the description as well. And it is giving you 1.11. And it is round figuring the value. And now let's discuss about ceiling. Okay. Ceiling is also, let's say, sometimes when we are doing round off function, what we do is we take the higher number. So ceiling is 3.14. So according to mathematics, through 3.14, if you are rounding it off to 0 decimals, that will become 3. But ceiling is one thing, it will take the greatest value instead of taking the lowest value. So now let's see. Now we have all these profit values. So I'm writing a ceiling function of sum of profit. And say apply. Ceiling. And say apply. Okay, if you see, we have 49,993.13. So according to mathematics, it is 49,993 if you are rounding it off. But as it is taking the highest value, it will go to the 94. So same goes for all the lowest ones. 58.36, so it will show you 59. So ceiling is the function which gives you the highest value. It rounds a number nearest integer of equal or greater value. So that is the usage of ceiling. Number function and cos, cot are same. So we don't use these calculations much, but if required, we use these calculations, and decrease also same div. Okay, so div is something. Let me create a new one. Div 11 comma 2. Apply. It just gives the division of 11 by 2, which is 5.5. To see that division, you need to make this as an average. Format, custom. So it gives us the integer part actually. So 5.5, whenever you are converting it, it will just show us the integer part. Okay. Now let's go to the other function. Exponential. So if you want to show the e to the power of 5 or e to the power of 6, say apply.